grab a coffee or 7 and let's get into it. Hey traders, so recently, as in recently of recording this video, TradingView released version 6 of Pine Script syntax. So the bulk of the video lessons in this course are recorded for version 5 of syntax, which was the version that we've run with for the past couple of years. Now, for those of you who are new to programming, syntax just means the way we express our code. It's kind of like grammar in English. There's different rule sets for each version of Pine Script. In the past, a version change usually meant big changes to how we express our code in Pine Script. But version 6 is a little bit different. It actually doesn't change the syntax of our code, so far at least, as of November 2024, when it released. It's basically exactly the same as version 5. So even though a lot of the lessons in the course are for version 5, the examples and the code expressed in those lessons should still work for version 6. If they don't, shoot me an email at support@theartoftrading.com and I'll fix that lesson. I'm going through that process now. That's why I'm recording this video, to put at the front end of the course. I will go through and try to update the source code of all the lessons to version 6. So if the video doesn't match the code version, don't be alarmed. The only difference from 99% of the scripts in the course should be the version change from version 5 to version 6. So in the video, it might say version 5 at the start of the script, but the code below the video will be version 6 syntax. If version 6 does break a feature of an existing lesson, I will re-record that lesson entirely. But so far, as of the release of Pine Script version 6, it does not break version 5 scripts. And they've made this change to version 6 because they've made a lot of under the hood changes to the back end of Pine Script to make it more efficient, better optimized so that it runs faster on our charts, so that our code executes much faster on our charts, which is better for everyone who uses TradingView because it's a cloud-based platform. It's a shared resource that we all use. I just wanted to ease any concerns for you guys that join the course, see that some of the lessons are in version 5 and wondering if that code will work with version 6. The short answer is yes, it will. If it doesn't, as I said, I'll fix that lesson, re-record everything, and explain how to do it in version 6. But so far, no changes to syntax, just improvements across the board to how Pine Script works on the back end. With that said, enjoy the rest of the course. All right, traders, let's have a look at the Pine editor to begin things. For those of you who are familiar with this, you'll probably want to skip this lesson. But for those of you who are brand new to Pine Script, this is what you will need to know about the Pine editor. First of all, you can find it by clicking on the Pine editor button down here. This is your script title. And to create a new script, you click on this little button here and come down to create new. And you can create an indicator, a strategy, or a library. For the start of the course, we'll focus on indicators because that is where most traders should begin. Strategies are obviously going to be more complicated. They enter and exit mock trades or demo trades in the strategy tester. We'll cover that later in the course. Libraries are also an advanced feature. You shouldn't really need to touch libraries unless you're creating complex scripts that share code amongst each other. So a library is like a bucket of code that can be referenced by any script that imports that library into its code. So it's a very useful feature, but it's quite an advanced feature that most traders won't need to use unless you're publishing your scripts publicly or writing lots of scripts that share code. So we'll cover that later on in the course. When you're first starting out, it could be useful to click on the built-in scripts here, and you can have a look at how TradingView have written their own scripts. So for example, if we come down to, let's do a moving average, simple. Click on that. This will open the code to the TradingView indicator source code. Now this is in version 5. The latest version of Pine Script is version 6. So it doesn't really matter. As you can see here, this is a giant mess. There's no commenting. It's not very organized. This is bare bones code. So don't be overwhelmed when you see this. Your code should not look like this. As I'll show you throughout the course, if you're new to coding, we'll do a much better job of formatting our code, explaining what the code does. So it's not just a wall of random gibberish text, and you can actually understand what your code is doing. To experienced coders, they can read this at a glance. But for beginner coders, this sort of formatting is terrible. So don't worry, throughout the course we'll write much better code than this and you won't be overwhelmed by the complexity. Let's go back to a blank indicator. So the main things you need to know about the Pine editor is this little drop down box here. First of all, you can rename your script. You can access your recently used scripts, and my screen is zoomed in here. If I zoom it out a little bit, you can also open a script that you've been working on. Any script that you've saved will show up in this list. So this is all the script related settings. You also have this button here. Click that to add your script onto the chart, and you can see what your code is doing. You can also publish an indicator here, which I'll show you how to do later in the course. We have our editor settings. So autocomplete is when you're writing code, you'll see this box pop up here. I would recommend leaving this turned on. There's no reason not to. It displays suggestions when you type. It saves us a ton of time. So now when you're typing, let's do a plot, for example. This draws things to the chart. If I hit Control Space, that will show me all the different parameters I can pass into this function. I'll explain what parameters are and everything later on in the course, but just know that hitting Control Space as you're typing will bring up code suggestions, and make sure to have that on. Minimap is this thing in the corner. So if I open a more advanced script, let's open up this one here and come to editor settings and turn on the minimap. On the right side of my screen here, you can see this sort of window here. This is showing what's currently visible in my Pine editor. And if I zoom out my chart to 100%, you can see that the highlighted section there is tracking what's visible on my screen. So the minimap is very useful for really advanced, complex scripts with lots and lots of lines of code. I personally don't love that. I usually leave that off unless I'm working with an advanced script, because it just adds clutter into my editor. I don't like it, but that's a matter of preference. I'd recommend leaving this off until you are more experienced with Pine Script. Status bar displays the status bar at the bottom. That is this guy down here. I'd recommend leaving that on. There's no reason not to. It also comes with the little compiler or console. This is where information is printed to your screen to tell you what your script is doing. If there's any errors in the script, they will show up down here. So you click this little button to bring that window up. We'll go over that later on in the course when we're actually making code or writing code. Line length guide will turn on. Again, if I zoom out my chart a bit, this line here that you can see, this gray line, is the recommended line length to make your code more readable. Personally, I don't like having that there. It is a good rule of thumb to keep your lines of code as short as reasonably possible. So for example, with this line function, if I had, let's add a lot of parameters. Let's add force overlay equals true, and we'll add style equals style, line.style solid. As you can see, this text goes off my chart. This line recommended guide thing here would typically be used to format your code so that you can keep everything on your screen and easy to read. Personally, I don't really like doing that. It's an optional thing to do. Personally, for some lines of code, I don't really care if it goes off my screen there. So I like to turn that off because it's, again, just less clutter in my editor, but that's a matter of preference. Inlay hints for imports. This is for libraries. I'd leave this on. Don't bother touching this. Same with this as well. Leave these two settings on. There's no reason to turn them off, and you'll see what they do later on in the course. I don't want to overwhelm you with too much information, so that's all you really need to know about this so far. Just to wrap up this overview, we'll go over a few other things here. You can open the editor in a new window and have that on your second monitor if you want to. If you close that window, it just comes back down here. You can open the editor in a new tab. I rarely ever use these features, but they're useful if you're working on a particularly complex script. Pine logs is very important. This will just show you debugging logs. Debugging is coding jargon for error analysis or bug analysis. We're looking for any issues in our script. We can print into this log what our script is doing, so that if we're working with a particularly complex indicator or strategy, we can print to this log using the log function. So if I detect that my script is doing something that it shouldn't be, I could write in here an error message, save my code, and now you can see this log is populated with an error message on every single bar on my chart, because this is executing on every bar on my chart. And you can see the timestamps there, the dates and everything. This is a very useful tool for figuring out what your script is doing if it's doing something that you don't want it to do. If your script has gone rogue, this is a good way to find out why. User manual is very useful, obviously. You can click this to open the user manual in a new tab, and this will tell you everything you need to know about Pine Script. It's not very easy to navigate. That's the whole reason I put this course together. A lot of us, including myself, learn a lot better visually and through examples and seeing people work through these concepts. But if you get stuck on something or there's something that's not covered in the course, this is the first place you should go, user manual. We also have the reference manual built into the chart itself. This is extremely useful for figuring out what certain functions do. So for example, if we want to know how to enter a trade, we can type in strategy.entry, click on this list item, and this will explain everything we need to know about the entry function for opening or adding to a position. Again, the information here is quite technical. It's not really written for people who are new to programming. Most documentation for coding isn't. It's mostly written for people who already know how to code. If you're not new to coding, then this is obviously a great resource to refer to when you're building out your scripts. And if you are new to coding, this is still a great resource, but obviously you'll want to go through at least the first beginner section of this course before you'll understand a lot of this. Another way to open up the reference manual, a really convenient way, is to hold down Control or Command on a Mac and click on the function name. So for example, if I want to know everything a plot can do, if I hold down Control and click on this, this will bring up the reference manual directly to that function and explain every input that we have to work with. Then we have release notes. This is great for active coders who want to stay in the loop and understand everything that Pine Script is updating. This is the first place you'll find the latest features added to Pine Script. Whenever Pine Script releases a major new feature, I'll typically create a YouTube video or add a lesson to the course and send out an email to everyone explaining what the new feature is. So make sure to stay subscribed to my mailing list if you want to be updated on that. Even if you cancel your subscription to the course, stay on my mailing list because I'll keep you guys in the loop on that. Finally, we have help. You have a bunch of keyboard shortcuts that you can use. A lot of these are pretty intuitive, like Control S or Command S to save your script, Control O to open a script, etc. I recommend reading through this for those of you who are very experienced with coding. For those of you who are not, maybe come back to this later on once you understand what you're doing. One last thing I want to mention is that we have this version control button here. So if I go back to this script, for example, and I click on this button, this will show me every time I've saved my script, it will show me the changes I made. So here you can see in red is code that was removed, and in green you can see the code that replaced what was in red. So if you make a change to your scripts later on when you're working in Pine Script and you screw something up that was working before, that's a common thing that programmers do. I'm laughing because I do that all the time. You know, I'll try to add a new feature to a script and break something entirely. This is a great way to fix that rather than having to save manual backups of your script, which is really difficult to do, and or at least difficult to remember to do. That's all done automatically for us in the version history, which is super convenient. So this is the latest version of my script. If the latest version of my script is broken and I want to revert to a previous version, I can click on one of these and click restore this version down the bottom right. That will revert my code back to that version. It'll still save the last version of my code, so this is a great way to jump around and to go back. And if you broke something in your script, you can maybe go back to the last functioning version of your script and start again with implementing whatever feature you were trying to do. Now, before we get into actually writing code, it's probably a good idea for me to go over some of the basic things you will need to know about the compiler for Pine Script. So the compiler is what compiles our code, converts it into information that TradingView's servers can understand. So all of this English written code will turn into computer code that the computer can run and execute our commands. The Pine Script compiler is responsible for doing that. So when I click save here, I'm just going to delete this script after. So I'll just name this delete. My script just compiled. And I know it compiled because I didn't get any errors. If, however, we do something like this, let me get rid of one of these parentheses here and save the script. Now we have a problem. We have a syntax error, this red line here. Now the wonderful thing about most programming languages and compilers is that they will usually tell you where the error happened. So we get the exact line that this error occurred on. It occurred on line 6, this line here. So that makes it really easy for us to, you can even click on this. It's a link that will take you to that line of code in your script. So if I click on that, it takes me straight there. Now, every error message will be different depending on what you messed up in your script. A lot of these error messages are quite cryptic. So end of line without line continuation, even I don't know what that really means. It's amusing to me, some of the error messages you get in some programming languages. Sometimes they're really helpful. Sometimes you're just like, wow, thanks, compiler. That was really helpful. So now if I close this off and save my script, we don't have any errors. The compiler compiled our code without any problems. Let's try getting rid of one of these quotation marks. Save the script. Now we get a different error, mismatched character. This character here means we have a new line starting. So Pine Script got to the end of this line and then a new line started, but it was expecting this quotation mark to close off this string of text. And so it threw an error on line 5. So most of the problems in your script are going to be pretty obvious and intuitive. When you see an error pop up, usually it means you didn't close something off, you missed a comma, you missed a bracket, something like that. And within just a few seconds of reading your code back, you should be able to spot the problem. Now, some errors will be a little more difficult to solve, but in Pine Script, it's very rare that you run into an error that can't be solved very quickly, because usually it's a result of a typo of some kind. And you don't even need to know what the error message means. You can just click on that line of code and see at a glance that you missed something relating to the syntax. I will cover errors in your code in much more detail in its own section of the course towards the end of the course. So if you run into any problems, maybe jump ahead and check out that section. But the last thing I'm going to show you here is what happens if we get rid of the compiler directive. If I get rid of that and save the script, now we're going to get all kinds of weird problems and errors with our code. The reason for that is that the compiler now doesn't know what version of Pine Script we're using. So right now we are using the original version of Pine Script, the versionless version of Pine Script, the first iteration of this language. I have no idea what the syntax is for that language. I wasn't around when that was a thing. I started using Pine Script when it was in version 3. And so recently version 5 has released. So I've had to learn the new syntax of Pine Script 3 times now. I started with version 3, so I learned version 3 syntax. Then it updated to version 4 and I learned version 4's syntax. Now we're on version 5. The good news is it's not that much different to version 4. If I set the version to 4, save the script, we'll still get the same error, because in version 4 of Pine Script, we don't use the indicator annotation function, we use the study annotation function to create an indicator. So now my script just compiled fine. And so it's very important that you keep this compiler directive in and that you get your syntax correct in your code. You don't need these comments if you don't want them there. This will compile just fine as well. The reason why we have this compiler directive that allows us to target older versions of Pine Script is for backwards compatibility. So there are hundreds, if not thousands of scripts that have been written from the beginning of TradingView's existence that are still very useful, even though they were written in an old version of Pine Script. And rather than force all of those coders to update their code to version 5 of Pine Script, TradingView simply allow you to target old versions of Pine Script so that you don't need to update your scripts for them to work. The only reason you would want to update your script to version 5 of Pine Script is to take advantage of the new features of that version. So I have dozens of indicators written in version 4. I'm not going to convert all of them into version 5 of Pine Script, except for the ones that I use regularly. Now, one last thing I want to mention about the compiler is that it is not particularly picky about where you put some of your syntax. For example, if you have a plot function that has a lot of parameters, which we'll cover in future lessons, you can separate them across multiple lines. Now, there are some rules with this that take some getting used to, but let me just quickly demonstrate what I mean by this. So for example, we could put a space between our plot and our parentheses, save the script, and this will work just fine. No problems, no compiler errors. We can also split our parameters across multiple lines. So if I press enter here and I tab indent this line of code and I save the script, we'll get an error. In Pine Script, if you want to indent your parameters across multiple lines, you need to put a space after your tab. So now if I save the script, this compiles just fine. So the purpose of being able to do this is maybe you have a bunch of parameters in your plot function that stretch way off your screen. You can separate these onto multiple lines to make it easier to read your code. So for example, if I put a comma here and then enter, I could say offset equals 1, comma, title equals plot close, comma, line width equals 2, comma, and let's set the color to color.black. And then let's move this parentheses down one line. Now if I save the script, this compiles just fine. So we'll cover this sort of thing in future lessons. I just wanted to make you aware of the fact that the compiler is quite flexible when it comes to your syntax, just so long as everything is in the right order and you respect some of the indentation rules, which we'll cover in future lessons as well. But anyway, I just wanted to make you aware of the fact that we can do this sort of thing in Pine Script. The compiler will allow us to separate our code across multiple lines under certain circumstances, as long as we respect certain syntax rules. I'll leave it there because I don't want to overwhelm you guys with too much information before we actually cover what all of these parameters do. But now at least you know that when we get into future advanced lessons, that this sort of thing is possible if you need to separate your code across multiple lines. Anyway, that about sums it up for the compiler. I'm sure we will run into other issues that I haven't covered here that we'll address in future lessons, especially the error section of the course. So I'll wrap this up here and I'll see you in the next lesson. All right, traders. So in this lesson, I'm going to be breaking down how comments work in Pine Script. So comments are basically a way of leaving notes in your code for yourself or for other traders or coders who read your script. So right here, I have a blank indicator script using the default template that TradingView have created. And you can see 2 comments at the top here. These are automatically added to all scripts that you create through the Pine editor. This top comment here is saying that our source code is subject to the terms of the Mozilla public license. And here's a link to that license if you want to read what this means. Here's the license here. And just really quickly while we're here, I figure we might as well go over this, as I'm sure some of you are interested in what this means if you haven't seen it before. But basically this just limits your liability as a coder. So it just says the covered software, which is our scripts, is provided under this license on an as-is basis without warranty of any kind. The entire risk as to the quality and performance of the covered software is with you, and you being the script user or anyone who uses your script basically is using your script at their own risk. Most open source software will operate under a license like this. And then next up we have our copyright. So this is a copyright, and then it will automatically insert your TradingView username here. Now both of these comments are not read by the Pine Script compiler. What that means is when the engine that runs your script through the TradingView platform does its thing, it ignores these lines. It's like they don't exist. And this is all the compiler will see. In fact, it will really only see this. So these comments are really just for your eyes only. And the way you write them is with 2 forward slashes. You can put them anywhere. They don't need to be at the start of the line. They could be after the line. So I could say here, declare my indicator. Here we could say plot the close. And you can even use them to comment out code. So let's say we want to get the RSI here, 14 period RSI on the closing price. Let's say there's a problem with our code, or there's something we want to test and we want to temporarily remove this code without deleting it. We can just add 2 comments in front of it, and now this code is ignored by the compiler. So that is the purpose of comments, to leave notes to yourself. One other purpose, which we'll cover in future lessons, is what's called annotation comments. So this right here is a annotation comment. It's a special comment that is not ignored by the compiler, but technically isn't code. You could think of this as kind of like metadata, if you're familiar with metadata. So this is just telling Pine Script that we want to work with version 5 of Pine Script. If we get rid of this and compile our script, we're now dealing with the original version of Pine Script, which had no version. And we're going to get all kinds of errors because of that, because the syntax of version 5 of Pine Script is very different to prior versions. And by syntax, I just mean the grammar of the language. The way we express our code is different in version 5 than any other version. If I bring back that annotation comment and save the script, now it compiles just fine. So that's the purpose of comments. We'll be using them a lot in our scripts. I highly encourage you to comment your scripts heavily. It's always better to have too many comments than not enough comments. The reason for that is there will be times when you write a script and you'll come back to it weeks, maybe even months or years later, and you might not remember why you did things a certain way or why your code was written the way it was. Having comments can help remind you why you did what you did, and it can help other traders know what you're trying to do with your code as well. So if you're writing public open source scripts, I definitely encourage you to comment them. And it's just a good idea in general to get into a habit of commenting your code regularly and extensively so that you know what you're doing. And it's kind of like, if you remember in school, when you did math stuff, you always had to show your work. You needed to explain how you got to your answer. Comments are basically the same thing. Using comments can explain how you got to where you got to in terms of your solution in your code. If I open up a script I've been working on recently, which is my Zen library, you can see that this script has, I think, more comments in it than actual lines of code. In fact, it certainly does have more comments in it than actual lines of code. Now, that's not a normal thing. You wouldn't normally see that in most scripts. But because this is a library, and we'll get into libraries in future lessons, so I don't want to overwhelm you with too much information, but each comment here explains what each block of code does in great detail. The reason for this is that this library is designed so that I could give it to a complete stranger who knows nothing about me, who knows nothing about how I like to code, and they can work out exactly to a T what every single part of my code does. If I got rid of all of these comments, the code becomes significantly harder to read because there is no explanation on what is happening. If I get rid of all of these comments and we're just left with this is not useful to most traders. Most traders will see this and they'll just move on to a different script because no one has the time to reverse engineer and deconstruct exactly what this code does. But by having all these comments, suddenly the script is much, much easier to read for anyone who is unfamiliar with what the code does. So that's the purpose of comments. We'll be using them a lot throughout the course. So as I said before, it's a good idea to get into a habit of using them. But don't worry, you'll see lots of examples of how to use comments in your code in future lessons. So if this doesn't quite make sense to you, don't worry, it will by the end of the course. See you in the next lesson. All right, hey traders, welcome back. In this lesson, we're going to be covering the indicator annotation function. Now, annotation function could be also thought of as like a directive function. It's a special function that tells Pine Script important information about the general nature of your script. So this comment here, our @version equals 5, is what's called a compiler directive. So this is directing the compiler to version 5 of Pine Script. It's telling Pine Script, the engine that runs Pine Script, to treat the code of this script by the rules of version 5 of Pine Script. The indicator annotation function does the exact same thing, except that it tells Pine Script to treat the code of this script as an indicator. The reason we need to use this is because there are a couple of different variations of script types. So we have strategy scripts. So if I call this strategy, that changes the rules of this script. If I say library, that changes the rules again. So we only have 3 to work with: indicator, strategy, and library. But each of those have different rules that govern your script. For this lesson, we're going to break down the indicator function, which is probably the script type that you'll be working with the most, especially in the beginning of your Pine Script journey. So let's break down the parameters of this function. So by calling this an indicator function, that gives this script access to a different subset of inbuilt functions and commands to work with. So for example, let's try and use a strategy function here. Let's say strategy.close. And we need to pass an ID here. Let's just say close our buy trade. If I save this script, we'll get an error here that says you cannot use strategy functions in indicator scripts. Please replace indicator with strategy. So that's why we need to use these annotation functions. If I change this to strategy, suddenly the script is treated differently by the Pine Script compiler. It has different functionality and features. But let's stick with indicator for this lesson, and let's break down what we can do with this indicator function. So if I hover my mouse over indicator and hold down Control or Command on a Mac and click on this function, on the name of this function, we'll get the Pine Script language reference manual popping up here. And this will tell us all of the various arguments we have to work with here. It'll give us a description of each one. I'm going to break down the most common ones here that you will most likely use in most of your scripts. So let's get rid of our title for a moment here and hover my mouse over this function name and we'll get a list of arguments. So the first one we have is title. So this is your long title. So let's say I want to call this my super fancy script. And if I save this and move this down a bit, you can see that my script name has changed there. And if I were to publish this script to the TradingView library, this is what it would be called on the TradingView library. This is its long title. This is its more descriptive title. But you can see that it takes up quite a lot of space on my chart. And if we had a lot of plots here, a lot of numbers plotting out here, having a long indicator title name could be a problem. So let's say we want to abbreviate this to MSFS. To do that, we just add in a comma here. All of our arguments in any function are separated by commas. So to add another argument or parameter to this function, we need to put a comma there. And then I need to pass in short title. And then this is a string as well. So we open up with two quotations. And let's say we want to call this MSFS. Now if I save the script, watch our title name here. It's now abbreviated to MSFS, but our official title is still my super fancy script. And if I were to publish this to the TradingView library, that is still what this script would be called. But when it's added to our chart, this is what it will say in the indicator box. So that's how our titles work. Next up, we have overlay. So by default, overlay is set to false. So if I save the script, having it set to false draws into its own box. You can see we're in our own oscillator box here, like the RSI or stochastics, MACD, those sorts of indicators. They are drawn into their own indicator box. They're not drawn directly on the price action like a moving average would, for example. But if you want to draw over price action, say you're working with a moving average script, for example, you want overlay to be set to true. Overlay just means it overlays over your price action. So if we set this to true and save the script, first nothing will happen because we've already added the script to our chart. So to update this particular parameter, we need to remove our script by clicking on this remove button here and then re-add it to our chart. So now when I click add to chart, overlay will be updated and it will be drawing over price action. So if I zoom in here, you can see that this script is just plotting the closing price. So it's connecting the closing price of all of these candles on my chart directly over price action. So that's what overlay does. Next up, we have format. So let's set overlay back to false and remove the script, save it, add it back to my chart. And let's say we want to plot volume instead of the closing price. So now let's save the script and it will update. Whoops. It will update and now it's plotting the volume of each bar onto my chart. Let me go out to the daily so that we get a higher number here. So notice this number down here is an exact number of the volume printed. It's not that readable. We don't really need to know the exact quantity of shares traded on a stock or in the crypto market, how many of a particular crypto asset was traded. In this case, we're dealing with ticks, price ticks on the Forex market, tick volume. We don't need to know the precise number. So if you are dealing, this is mostly useful for volume. I don't really know of any other use cases where you'd want to do this, but this format parameter that you can see down there above the blue underline, format can be set to format dot, and if I press Control space or Command space on a Mac, you get a list of the various formatting options we have to work with here. I'm not going to go over all of these. You can play around with these in your own time to see what they do. It's not often you will need to change the format of your script anyway, but in today's example, we're dealing with volume right now. So let's click on volume and save the script. Now keep an eye on this number here. It's now changed to a smaller number with a K after it. So if I hover over the last bar on my chart, that says 6.037K. So roughly 6,000 volume on this latest bar. So that's the purpose of the format parameter in the indicator function. Next up, we have precision. This is your decimal precision. So let me get rid of this format for now. And let me get rid of this really quickly and save the script to update it. The precision argument changes your decimal precision of the numbers that draw onto the chart in your script. So by default, the precision is going to be set to the decimal precision of your price. So right now we have 5 decimals here on euro dollar. If we were to go to a different market like Bitcoin, for example, now we have a 2 decimal precision. And you can see after the decimal place here, we have 2 digits. But if we wanted to override that to a higher precision or a lower precision, we can do that using the precision argument in this function. So let me set this to 5 and save the script. Now you can see 5 decimal places after the decimal place on this script. Now, in this particular case, we're just plotting the closing price, so that's not that useful, seeing 5 extra or 3 extra decimal places on this price value. But what if we were plotting other values, other indicator values, where we wanted to see those extra decimal places, but we couldn't see them because of the number of decimals on our price? So for example, what about a relative volume indicator? Let's say we want to compare today's volume or this bar's volume to the average over the past 10 days. And we want to know that number to a 3 decimal precision instead of just 2. That's where this argument comes into handy. You can change the precision, override the precision of your indicator plot values with this argument. We will be using this in future lessons, but for now, we can move on. I'll show you practical examples of this later on in the course. Next up, we have scale. So this is the axis, the scale axis you want to plot your values onto. So by default, your indicator is going to plot onto whatever price axis you have on your chart. So in this case, we have price plotting onto our right axis. But if we wanted this to plot onto our left axis, for example, you can use the scale argument here. So we can set scale to scale dot control space. Let's set it to left and save the script. And we need to remove the script to update this and add it back to our chart. Now you can see that our values here are being plotted onto the left scale, not the right scale. So again, not often you will need to do this, but there is the option to if you need to. Let's get rid of that for now. Save the script, remove it, add it back to our chart. So whenever you're dealing with a visual update like scale or overlay, you need to remove the script and re-add it back to your chart. So if you make a change to your script and it doesn't update, a general good rule of thumb is to try removing it, add it back on. That will force TradingView to update your script entirely. Now the next parameter we have to work with is max bars back. This is not something you will often use in your scripts. I've never used it in my scripts, to be honest, but it's here if you need to use it. Now this tells the script how many bars back it can reference from whichever current bar it's calculating on. So if we're looking at the final bar on my chart and we set max bars back to 10, for example, and I save the script, whatever code is running on this last script, this last bar on my chart, this script can only reference the past 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 bars. So only this price action here. Now, personally, in my own coding, I've written dozens of scripts over the years. I've never used this feature. I've never used this max bars back. I've never had to. I've never had a reason to. But if you do run into a situation where you need to use this function, this feature, this is how you would do it. You can set your max bars back to 10. Just keep in mind that this is in reference to the current bar. So when your script is running over historical price action, each bar on your chart can look back 10 bars. And then this bar can look back 10 bars, and then this one, etc. So that's how that argument works, but let's get rid of it for now since we would rarely use that. The final parameter I'm going to cover here that is commonly used is time frame. So time frame specifies what time frame your script can run on. So for example, let's drop down to the 4-hour chart and change this to D, short for daily, and save the script. Now my script is plotting the daily time frame closing price onto my chart instead of the 4-hour. So if I zoom in here, you can see that each time this updates, we get a new value down here. So on this bar here, a new day began, and the previous day's closing price was 54690. And then on the bars in between, we get NA because these 4-hour bars are plotting in between the next day. And then on that next day's beginning, we get the previous day's closing price, which was 57487, and so on. So that's one way to hard code your script to only reference a particular time frame. I wouldn't recommend doing this. There are better ways to do this, depending on the script. If you have a script that you only want to reference a particular time frame, you might want to hard code it this way. But if you have a script that you want to be able to use on multiple time frames, you're better off using user inputs to specify the time frame of your script. And we will cover that in future lessons. I don't want to overload you with too much information, so we'll leave this lesson here. If you want to see what these other parameters do, again, just hold Control and click on this function name, and you'll get a list of the arguments we have here with detailed descriptions on how they work. But anyway, that'll do it for this lesson. I'll see you in the next one. Hey traders, in this short lesson, I will introduce you to the concept of namespaces. So namespaces in Pine Script are what we call the keywords that contain certain functions or variables. So that might sound a bit confusing, but when I show you a visual example, it should make perfect sense. There are several namespaces that we have access to in our Pine Script code. The first one I'm going to show you is the technical analysis namespace. So for example, let's say we want to get the RSI value. To do that, I can create a new variable called RSI, and we can assign this variable or initialize this variable using the equal sign. So RSI is set to, and then we need to reference the TA or technical analysis namespace. So if I write TA here, then a full stop, and then control space or command space on a Mac, we get a list of all of our technical analysis functions. So if I start writing RSI, here is our RSI function. And you can see here that it is underneath the TA or technical analysis namespace. So if I click on that, we pass in a price source, so close, and 14 default period. There we go. We have an RSI value. And if I cut this plot down here and change the plot from the closing price to the RSI value we just retrieved, and I save the script, we're now plotting the RSI. So Pine Script makes it really easy to access all of the most popular indicator tools that traders typically use, and you'll find all of your indicator functions under the TA namespace. So that's really it for namespaces. That's all you really need to know. You can also create your own libraries. We'll cover that later on in the course, but when you create your own custom library, it behaves pretty much identically to these inbuilt namespaces. So for example, if I type in import Zen and the art of trading, control space, here is one of my libraries I've created. If I import this as Zen, I can now reference my Zen library namespace, the same way we did the technical analysis namespace. So for example, if I write here Zen dot control space or command space, we get a list of all of my custom functions. These are functions that I created, that I wrote in my own code in the Zen library script, and I published this to the TradingView platform. I can now reference all of these functions the same way we can reference the inbuilt functions that TradingView offers, or Pine Script offers. But as I said, we'll cover libraries in a future lesson because it is quite an advanced concept. So I just wanted to make you aware of that feature. And so you can basically think of a namespace as a collection of functions or tools that you've written, either you've written or the TradingView Pine Script developers have created. So before we end this lesson, we'll go over just a couple of other namespaces. For example, if we're dealing with strings, so text, this is a string right here. If I create a variable called myString and we just call this a string of text, I can now use the string namespace. So str is short for string. If I put in a dot and then control space or command space, we get a list of all of the different functions we can use relating to strings. So for example, if I set this to the text 10, and then I use the to number function, and we pass in my string. If I cut that and paste that into our plot and save the script, we are now plotting the number 10 after using the string namespace to convert this text into a number. And there are a whole bunch of other namespaces. We have the strategy namespace when you're dealing with strategy scripts. So you have your trade commands and various variables that you can reference, such as your current account balance and things like that. We also have the request namespace, which we'll cover in future lessons. This is where you retrieve or request financial data about stocks. You can reference Quandl, which is a third-party resource that offers all sorts of things like sentiment, interest rate information, all kinds of stuff. We'll cover Quandl in a future lesson. And then we also have the security function here, which we use to reference other symbols and other timeframes. So you use the request.security function to request, for example, we're on euro dollar 1 hour chart here. Maybe I want to check what the daily high and low is, and then plot that information over this 1 hour intraday time frame. To do that, we would use the request.security function. And so that is a quick crash course on Pine Script's namespaces. And we'll be using these frequently in our scripts. So you'll get used to using these and you'll soon memorize them all very quickly. Anyway, that's it for this lesson. I will speak with you in the next one. All right, traders, welcome to the price series lesson. In this lesson, I'm going to be showing you how to reference candlestick price data. So your open, high, low, and close. This is obviously going to make up the backbone of most of your scripts. You're going to need to reference this data very frequently in your scripts, since what is price analysis without referencing price? So it's quite simple to access this data. Obviously, the challenge comes with what you do with this data. First of all, let me get rid of precision 1. That's from a previous lesson. So here I have a blank script. Let me save the script to show you. So we're just plotting the closing price onto our chart. So by default, this is the default template for any new script. We already have our closing data being referenced. And to reference the other price points on your chart is as simple as you might think. So let's say we want to get our candle open price. I'm going to declare a new variable here called candle open, and it's going to be set to the open price value. Next up, we'll get our high. So candle high is set to high. Then we can get our candle low is set to the low. And then candle close is set to the close. Now, you don't normally need to do this. You can just directly reference open, high, low, and close in your script. But for today's example, I thought this might be a little more intuitive to see what's going on here. So now let's save the script and let's draw these values onto our chart. So I'm going to use a comment here, say draw candle data onto our chart. I'm going to paste candle open in there, copy this, and I'll paste it 4 times. And I'll just paste in each variable here. And let's change the color of each plot, because if I save the script now, we're going to get 4 blue lines drawing onto our chart and we can't tell what's what. So let's set the color of the open to color.blue. And now I'm going to copy this line of code and paste it in. And let's change the color of each data value here. Let's change the high to red. We'll change the low to green. And let's change the close to purple. And save the script. We should get 4 different colors plotting onto our chart here now. And each color corresponds to each candle price. So it's as simple as that to get our price data, which is what we're doing here. So now let's say we want to do something useful with this data. Let's say we want to get the current bar's size in points. So we want to subtract the high from the low. So now let's create a new section of code here, and I'll say analyze price data. And for this, we're going to create a couple of variables. The first variable we create is going to be called candle size. And to calculate the candle size is really easy. All we need to do is subtract the low from the high. So high minus low will give us our candle size in points. And let's plot this onto our chart as well. So we'll call this candle size. We'll set this to color dot orange. And in fact, let's comment out all of our open, high, low, close, because we don't really need to see that data on our chart. Save the script. We should be getting an orange line drawing here now, which is showing the candle size in points or pips in this case. So right now, as I hover over the last bar on my chart here, our candle size is 6.9 pips. So as you can see, it's really easy to analyze price data. Obviously, it gets more complex the more complex analysis you're doing, but it's really simple to access this data and to analyze it. Let's try something a little bit more complicated to demonstrate the historical operator. So let's say we want to reference a historical bar on our chart. This will reference the current bar, and this will run on every bar on our chart. So as I hover my mouse, let's hover over this bar here, which is quite large. If I hover my mouse over that, you can see down here, this number says 65.2 pips. So this script is running on each historical bar on our chart. And so every bar on our chart will reference its own open, high, low, and close. But what if we wanted to reference, let's say 10 bars back? So we want to reference 10 bars in the past. Let's go back to our current bar. And let's say we want to compare the current bar's candle size to the candle size of a bar 10 bars ago. To do that is really simple. Let's just create a new variable here called candle size 10. And we'll set that to the high of the bar 10 bars ago minus the low of the bar 10 bars ago. So to reference historical data, we use square brackets, and then we pass in a number, an integer number, a whole number. And this whole number is your look back count. Hey guys, Editing Matt here. I just wanted to interject really quickly because I realized while editing this video that I forgot to mention something very important for beginner programmers to understand. In programming, when we are dealing with things like bar indexes, so that's what this is, here I am plotting the closing price of the bar 10 bars ago. I forgot to mention that in programming, when we're dealing with things like lists of data, which is what this essentially is, we don't start counting from 1. We start counting from 0. So what I mean by that is plotting the closing price of the bar index of 0 onto our chart. If I save this script, that is exactly the same as just plotting the closing price. But if I plot the closing price of the first bar in our price series, and also another thing that's important to mention is that these bar index numbers begin from the last bar on your chart. So we are counting backwards when we are dealing with the price series or historical operator. So the higher this number is, the more bars back we are referencing. And so 0 would be the current bar. That's why if you bring out your measuring tool, if you look down at the bar count here, it says 0 bars on the current bar. And then the bar next to it is minus 1 bar. So plotting the closing price of the bar index of 1 means we are plotting the closing price of the bar 1 bar back from the current bar. And so if I put 10 in here, then we are technically plotting the closing price of the 11th bar back from the current bar. So if I count out 10 bars here, that puts us on this bar right here. If I count the bars from this bar to the current bar, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So technically speaking, we are counting back 11 bars from the current bar when we reference 10, because we start from 0, 0, 1, 2, 3, 4, 5, and so on. So that is an important thing to mention. When I say something like I'm referencing 10 bars ago, I mean historical bars, 10 historical bars ago. It's an important distinction to make because when we get further into the course and we do things like detecting candlestick patterns, it does matter that you get this number correct, obviously, because if you have it even one bar off, that's going to mess up your pattern detection code. But anyway, I thought that was just important to mention. In coding, in Pine Script and all programming languages, all counting of all kinds when dealing with lists of data start from 0. So we have 0, 1, 2, 3, 4, and so on. 0 counts as 1. And so you've pretty much got to shift everything up a number when dealing with indexes. And that's what this is. This is a bar index. The bar index just means the bar count from the current bar. So this would be a bar index of 0, bar index of 1, bar index of 2, and you get the idea. Anyway, that is just some really important information I need to make you aware of. Let's get back to the lesson. So this will get the candle size of the bar 10 bars ago. So let's compare these two values. To do that, we'll say candle size ratio, and we will divide our current candle size by the candle size 10 bars ago. And let's plot that onto our chart as well. Candle size ratio with a color of purple. So when I save the script, we'll be getting another line drawing onto our chart that is comparing the current bar size to the bar size 10 bars ago. Save the script. And there we go. So the current bar is 130% the size of the bar from 10 bars ago, or 1.3 times. And it's that simple. That's how we reference historical price data. Very easy. And this historical operator works on any series of data that we can reference in Pine Script. So this applies to indicator values as well. It applies to basically anything that has a series of data that we can reference. So for example, let's say we wanted to get the ATR value of the current bar. To do that, we could just create a new variable here called ATR is set to ta.atr, and let's just pass in the default 14 length period. So this will get the current ATR value. And let's say we wanted to plot the ATR from 10 bars ago. We can do so just like that. So this plot function now will reference the ATR value from 10 bars ago. Save the script. And now our white number here is drawing the ATR of 10 bars ago. Really, really simple to reference historical data. And this applies to anything, as I said. We could reference the volume from 100 bars ago if we wanted to. Let's say 234 bars ago. Save the script. Now our white line is the volume from 234 bars ago. There is a limit to how far back you can look. So if I set this to 999999 and save the script, we'll get an error. You can see this little warning sign pops up here. If I click on that, it says too large, max total bars back. And then we have our large number here. The maximum is 300,000 bars, which is still quite a lot of bars. So let's set this back to, let's say 10, save the script. And there we go. So that's how you reference open, high, low, close data. That's how you reference historical data using the historical series operator. And this technique applies to any value, indicator values as well. So if we wanted to compare the ATR from 10 bars ago the same way we did here, we could just say ATR 10, and then ATR ratio is ATR divided by ATR 10. This will work just fine the same way this did. Now, obviously, this is a pretty useless example of how to use price series and indicator series in our scripts. But in future lessons, we'll be covering more complex, more practical demonstrations of analyzing price action using this information. And that brings me to the end of this lesson. I'll see you in the next one. In this lesson, we're going to be covering the fundamental commonly used data types that you will be using in most of your scripts to perform your calculations and analysis. The first data type you're going to be working with in all of your scripts, for the most part, will be number types. So there are two types of numbers in Pine Script. We have integer type. This is whole numbers. So for example, 1 would be an integer. This could be 1, 10, 100, 20, whatever. Just as long as it's a whole number and there is no decimal in it, that will be called an integer. Next up, we have float type. This is like an integer, except it has a decimal place after it. So any number with a decimal place is considered a float. The reason this is called a float type is because there is no fixed number of digits before and after the decimal place. So the decimal place can float around, and so that's why they call it a float. Programming can be weird like that. Don't ask me why that became a thing, but you'll get used to it. So there's a lot of technical jargon you'll need to learn in coding. Integers just mean whole numbers. There is more nuance to this. For example, there is a maximum number that an integer can be, but you don't need to know about that because it's extremely unlikely you're going to run into that issue in Pine Script. I certainly never have in the 3+ years I've been working on all kinds of scripts. But anyway, moving on, we have our floating point numbers, float type numbers. For example, a closing price is a float because there's a decimal number in it. You can see here on Bitcoin, we have 2 digits after the decimal place. That means that this price here is a floating point data type. Next up, we have, it's not another data type, it's just a different way of using floating points. So float type E, we'll call this. And if I were to say 0.1 and then use the mathematical operator E and then put 2 on the end here, what this is saying is return the number or the result of this equation, which is 0.1 times 10 to the power of 2. Now, it's not often you'll need to use this, if ever, but the option is there if you need to, or if you're mathematically inclined. For me personally, I'm terrible at math, which is interesting considering I became a trader and programmer. But that's the beauty of modern programming. You don't need to be good at math to be a programmer. But if you are talented at math, this is a tool at your disposal. The next data type we have to work with is what's called Boolean values. So a Boolean data type is simply yes or no, true or false, 1 or 0. In Pine Script, it's represented by the word true and the word false. So a bool type or Boolean type would look something like this. True for true, false for false. So let me leave that as true. This is quite simple to understand. You'll use this data type quite a lot in your scripts. In fact, these first 3 data types will make up the majority of your scripts in terms of how you calculate stuff. The next data type we have that will be commonly used is color types. So color types in Pine Script are their own data type. And to reference color data types, you can use the inbuilt data types that Pine Script provide. If I type out color and then a full stop and hit Control space or Command space on a Mac, and I scroll down, you can see a list of inbuilt colors here. So if I say color.red, that will give the Pine Script inbuilt red color as a data type. And this can be passed into any of my drawing tools. So for example, we've got a plot here that is plotting our float type E. If I change this to say color equals color type, whoops, and I save the script, our line will turn red. So you can see there. So that's what color data types are like. You can also use hexadecimal colors. So if I wanted to color this red in hexadecimal, that would look like FF0000. If I save that, we get bright red. We'll cover hexadecimal colors in a future lesson. You don't need to know them in order to use colors in your script. But if you are familiar with hexadecimals from web development, primarily these are used in web development. So if you're familiar with working on websites, you'll know how hexadecimal colors work, or you can use a hexadecimal color picker. Just look up hex color picker on Google. And this can be an easy way to fill out custom colors in your scripts. One other option we have to work with in Pine Script is the color.rgb function. This we can pass in 3 values, or 4 values actually: red, green, blue, and transparency. So for example, if I wanted full red, I could type in 255, 0 green, 0 blue, and 0 transparency. Now the transparency is optional. If I just put in RGB as 25500 and save the script, this will stay red. Actually, let's change this color so that we can actually see the difference. So this will now be bright green. There we go, because we've set green to full. So RGB colors range from 0 to 255, 0 being none and 255 being the maximum. And if we wanted to change the transparency, let's say we wanted to make the line completely transparent, we could set transparency to 100%, save the script, and now the line will disappear from our chart, but it's still plotting up here. So that's one way of plotting values onto your chart without the user seeing the actual line being drawn. I use this quite a lot in my scripts to draw information onto the chart that I want to reference in my indicator values, but that I don't want to see on the actual chart, such as stop loss sizes and things like that. Don't worry if this was a bit confusing. We'll cover color types in future lessons in great detail and in more practical examples. The next data type we have to work with that you will commonly use in your scripts, not all scripts, but some scripts, will be the string data type. So this will be string type equals text. So string is just what programmers call text. And in order to define it, we need to put 2 quotation marks on either side of our text. The reason why we do that is if we just say text here, then Pine Script doesn't know the difference between this and an actual function or variable in our script. If I save the script, we'll get an error here. It'll say undeclared identifier text. If we put quotation marks around it and save the script, we'll get no error because now Pine Script knows that this is text. Now you can use quotation marks or you can use single quotation marks as well. That will work just the same. If I save the script, this is treated exactly the same as if we'd used quotation marks. So it's really just a matter of preference, which one you use. I prefer to use the double quotes personally, just because I'm used to that from other programming languages. But if you're experienced in a different language and you're used to using single quotes, you can use them in your scripts if you want to. And just as a side note while we're here, if you want to include a single quote in your text, you can't just add another single quote because now that's treating this as a string and then we just have a single quote on its own. If I save the script, we'll get an error because we didn't close off this string here. If we add a backslash in front of this text, Pine Script will now know that we want to include this quote within our string. Then this backslash is telling Pine Script we want to include this single quote within our text. So for example, let's change this to ITS bullish. Now, if we were to draw this onto our chart using a label or any other text drawing function, a table or something like that, this text would display on our chart as this. So this quotation would be included in the text and the backslash would be removed. So that's the purpose of the backslash. You can also do things like \n, and that would move bullish onto a new line. And so if we were to draw this onto our chart, it would look like this. It's bullish on a new line. There are several escape characters you can use in your strings. We won't cover that in today's lesson because it's outside the scope of this lesson. I'm just introducing you to these concepts. I don't want to overwhelm you with too much information. And so let's just get rid of all this and go back to text. And we'll cover escape characters and stuff like that in future lessons. So before we wrap up this lesson, let's plot all of these types to our chart. And we'll just have a quick look at what they look like. So we have integer type, float type E, and bool type. We can't plot a boolean directly onto our chart, so we can only plot these numbers at the moment directly onto our chart. So let me change this to color.white, and I'll change this to color.white as well, and we'll save the script. So now you can see that we're plotting our integer type as 20. It's just a whole number. And then our float type, let me change my float type to 33.3 and save the script. Now here's our float type, 33.30. Now remember in a previous lesson I talked about precision of your script. Because we have 2 decimal places after our market price, we have 2 decimal places on our indicator values. So even though I set this number to 33.3, it displays as 33.30. If I didn't want that, I could change my precision to 1, save the script, and now it's only plotting to 1 decimal place. And so here we're plotting our integer number as a whole number, our float number, and then our float type E number. And in our integer plot, we are passing in our color type. Now let's use our bool type here. Let's say if bool type is true, then let's overwrite our color type to color.red. So now when I save the script, this color here, this plot will turn to red because bool type is set to true. And we just said if bool type is true, override color type with the color red. And to override something, we need to use the colon equals symbol. We can't just use equals because that's declaring a new variable. We want to overwrite this variable with this new one. And don't worry, we'll cover this in future lessons. I'm just showing this to you before we wrap this lesson up, how bool types work. So now if I save the script, this color will turn red because bool type is true and we've overwritten our color with red. If I change this to false, the color will go back to green because bool type is no longer true. Save the script. There we go. So that's it for this lesson. There are several data types here that we'll work with. These are the common data types. There are other data types too, like tables, labels, drawing objects, things like that. But we'll cover those in future lessons once you become more familiar with the basics of Pine Script. So don't worry if you are overwhelmed by any of this lesson. Throughout the course, we'll be using all of these data types quite regularly in practical scenarios. And over time, you'll learn how they all work and how you can use them in your own scripts. So that'll do it for this lesson. I hope you're enjoying the course so far. And if you are, stick around because it's about to get a lot more interesting. Hi, welcome back to another Pine Script lesson. In this lesson, we are going to be covering how to appropriately or correctly declare your variables in your scripts. So variables are used in all programming languages. We've already covered a few examples of them. In this lesson, we're just going to keep things simple and cover the basic fundamentals of variable declaration. In order to declare a variable, we need to basically give it a name. And then that name is like a key. So we have a key and a value. So in today's example, we're going to be counting candles in our chart. So I want to count how many green candles are on my chart. So I'm going to say green candle count is set to 0. So right here, we have declared a variable. We've declared a variable with the name or key, green candle count, and we've given it the value 0. Now, Pine Script will automatically determine what data type your variable is based on what value you give it. So Pine Script knows that 0 without any decimal places is an integer value, a whole number value. So whatever we do with this variable will be treated as an integer value. If we were to add a decimal place like 0.1, suddenly this becomes a float. And now whatever we do to this variable needs to be governed by the rules of floating point numbers. And there are certain things you can and can't do with data types, so it's important that you understand how the data types work. The good news is you'll pick this up throughout the course. It's not particularly complex, but it is important that you understand how data types work. Now you can explicitly tell Pine Script what type of variable you want. For example, if we wanted to tell Pine Script that this green candle count needs to be a float, we can just add the word float in front of it and save the script. And now Pine Script knows that even though there's no decimal place after this whole number value, this essentially becomes 0.0. Pine Script is now treating this as a floating point number, even though we gave it an integer value. Now, if we were to change this to text, for example, a string, this won't work. If I save the script, Pine Script says declared type float is not compatible with the assigned type string. So whatever data type you give it, you need to make sure it's accurate. But the option to explicitly define what data type your variable is possible using these data type operators. So this can be useful in certain situations. For example, if I get rid of this and I set green candle count to NA or not a number, this is basically null, nothing. I've set green candle count to literally nothing. It's not a data type of any kind. If I then want to draw that onto my chart, so let me paste the green candle count into the plot, save the script. You can see that it says down here, line 7, value with NA type cannot be assigned to a variable that was defined without a type keyword. So we cannot declare green candle count as NA, but if we add float on the end and save the script, this will now compile, and we are now plotting NA onto the chart. So that is one useful way of declaring a data type with nothing as its initial value. So we don't want this to be 0. We want this to be nothing. The only way to do that is to explicitly give this variable a type keyword. But we don't usually need to do this, so I'm going to get rid of that and set this back to 0 and save my script. So now we're plotting just 0 onto our chart on every bar. Now let's say that we want to count every green bar on our chart. To do that, we need to check if the closing price is greater than the opening price, then set green candle count to green candle count plus 1. Now notice that I used the colon equals operator here and I didn't just set equals. Now the reason for this is because once a variable is already declared, in order to overwrite the value that we've given this variable, we need to use the colon equals operator to reassign this variable to a new value. So for example, if I set this to 50 and I save the script, we will still be plotting 0 here and we get an error or a warning. This orange writing down here is a warning, not an error. It's just bringing to our attention that maybe we made a mistake. It says here that shadowing variable green candle count exists in the parent scope. Did you want to use the assign operator instead of the initialize operator or equals? So when you're first declaring a variable, you need to use the equals. That initializes the variable. You can't use the assign variable until the variable already exists. So if I save the script now, we'll get an error that green candle count is an undeclared variable. So the equals sign is for declaring a new variable, and the colon equals is for reassigning an existing variable a new value. So now if I change this to colon equals, instead of plotting 0 onto our chart, like we do here, if I use the colon equals, we will now be plotting 50 because our green candle count is being overwritten with the number 50, but only on bullish bars. So let's say we want to count all the green bars on our chart. To do that, we need to set green candle count to green candle count plus 1. So that will increment this variable by 1. It will get whatever its current value is and add 1 to it. So let me save the script here. And you'll notice that on each bullish bar in our chart, we were only drawing 1 onto the chart. And on bearish bars, we draw 0. The reason for this is that our variables are re-declared on every new bar on our chart. So every time a new bar, historical or real time, begins drawing onto our chart, our script code is run all over again. It just keeps looping our code. So every time our script runs, green candle count is set to 0. And so it never gets past 1 because on every new bar, this code is run again, green candle count is reset back to 0, and then incremented by 1 on bullish bars. If we want this variable to not update on new bars, but to persist across all of the bars on our chart, we need to use the VAR operator. So VAR converts this green candle count variable into what is called a persistent variable. So this variable will now persist across all of the bars on our chart. And so whenever we detect a green bar, the green candle count will increment by 1. Whenever we encounter a red or bearish bar, nothing will happen because our little if statement here will not be true. And don't worry, we'll cover if statements in more detail in future lessons. But for now, if I save this script, we will now be counting every green bar over historical price data. So if I save the script there, you can see that our line is incrementing slowly from bottom left to top right. If I reset my chart and hover over this last bar on my chart, we have 11,771 bullish bars on our chart from whenever our historical price action began. So that is the purpose of the VAR variable. Now the reason not all variables are VAR variables are because let's say we want to draw a shape whenever we detect a bullish bar. If I change draw shape to true and then we use the plot shape function, and we pass in our draw shape variable. If I save the script now, you can see an X plotting in our box whenever a bar is bullish. So for every green bar here, we have an X. If I change this draw shape to a VAR variable, and I click save, all of these bars will have an X above them, because the very first time we detect a bullish bar, draw shape will be set to true, and it will never reset back to false because we're using a VAR variable. So let me save the script here to show you what I mean. Here you can see we have all these X's. If I go back to the very first bar on my chart using the Alt-G shortcut, here you can see that the very first bar on our chart is bullish. And so draw shape is set to true, and it is never set back to false because this is a persistent variable. And so we draw X's on every single bar. If I get rid of VAR and save the script, now draw shape is reset on every new bar on our chart. And we want that to happen in this case for this particular variable because we want it to be reset on every new bar. We want each new bar to be considered as a brand new calculation. So that is why not all variables are persistent with this VAR tag, and we need to explicitly tell Pine Script when we want a variable to be saved across all of the bars on our chart. This VAR can be useful for all kinds of things, such as saving your stop loss and target until one is hit and drawing that onto the chart. It can be useful for keeping track of certain market conditions. So for example, maybe you want to check when the RSI goes overbought. So you would set your VAR variable to true when the RSI goes overbought, and then you want to wait for a bearish candle. And once that happens, maybe you enter short, for example, and then maybe you reset your RSI flag or your RSI overbought monitoring variable. Those are some practical use cases for this variable type. But let's get rid of our draw shape variable here for a moment. And let's just count every single bar on our chart. To do that, we can rename our variable to total bars and get rid of our if statement and get rid of this and just plot total bars down here. Now, before we continue, I should probably quickly go over the naming conventions for variables. The most important thing you need to know is that variables cannot start with a number. So if we change this to 1 total bars and save the script, we'll get an error down here because you cannot start a variable name with a number. You can have it after text, so we could say T1 total bars and save the script. That will work just fine. You can have any number on the end of your variable name, and that will work just fine. You can have an underscore in front of your name, your variable name, and that'll be okay. You can't use any other symbol, so we couldn't use a $sign, for example. That will give us a compile error. So you can only use underscores and text to begin your variable name, and you can have numbers and underscores in your variable names. But that's as creative as you can get with your variable names. So that's important to keep in mind. But anyway, let's wrap this lesson up by counting how many bars in total have drawn onto our chart. To do that, all we need to do is increment our total bars by 1 whenever our script runs on a new bar. So let's save the script and see how many bars drew onto our chart. There you can see a diagonal line all the way from bottom left to top right. You can see that we've had 23,553 bars plotted onto our chart in total. You could also get this number by using the bar underscore index. So if I plot that onto our chart, you can see we get the same number minus 1. The reason for that is that everything in programming starts from 0. And so the very first bar on our chart is considered bar index 0. And our script would have incremented our total bars to 1. So in our script's case, let's plot total bars with a color of color.purple and save the script. Now we'll get 2 lines drawing offset by 1. So if I hover my mouse over this very first bar, you can see that our script says that this is bar number 1, whereas bar index says it's bar number 0. The reason for that is that our total bars number is incremented on the first bar, whereas bar index is not. It's only incremented after that bar is finished drawing. So it starts from 0, 1, 2, 3, so on, all the way to our final bar. And our total bars starts from 1 and counts all the way up to the last bar. So that about does it for our variable declaration rules and fundamentals. We'll be covering variable declaration in quite some detail in the lessons to come and in much more practical use cases. So again, if this is all brand new to you and you're a little bit overwhelmed, don't worry. Just keep going through this content and eventually it will start to click. You can always rewatch the lessons or send an email to support@theartoftrading.com if something doesn't make sense to you, and I can help guide you to understand these concepts better. But with that said, that brings me to the end of this lesson. I'll see you in the next one where we will cover getting user input in your scripts. See you there. What I am about to show you is a bit of an advanced concept. So if this goes over your head, don't worry about it. Just keep moving on with the course. But for those of you who are experienced at coding, you need to know this early on. And for those of you who are not experienced with coding, this won't really affect you until you start developing complex scripts. So don't worry about it too much just yet. If this is the first scripting language you are learning, don't panic if this information goes way over your head. It's not something you need to worry about just yet, but it is important to know. So I want to briefly cover this early on before we start building out more complex scripts. Something important to mention about Pine Script version 6, which was recently released as of recording this video, is that when we're dealing with Boolean operators, which remember is true or false values, if I have something like this, let's say I have test Boolean equals, and let's say I want to check if the current bar closes higher than the previous bar's high, so a higher close. I would say close greater than high. And now let's say I also want this bar to be the highest bar over the past 10 bars. So I would say and high equals ta.highest high 10. This would check, does the current bar close higher than the previous bar's high? And is the current bar the highest high over the past 10 bars? This bar right here would meet that condition. It closed higher than the previous bar's high, and it is the highest bar over the past 10 bars. Now the issue is with this statement, and the reason this is highlighted or underlined in orange, is this function needs to be checked on every single bar on my chart in order to generate a correct value. So this function needs to run every time my script executes in order to be accurate. In version 5 of Pine Script, this would work just fine, but in version 6, we would have a problem. In version 5, this entire statement would get executed regardless of whether one check failed. But in version 6, Pine Script uses what is referred to as lazy evaluation. The script runtime engine is as lazy as possible when evaluating the statement. And what will happen is, if the current bar does not close higher than the previous bar, then this code never gets executed or checked at all. In version 5, both of these checks would be run simultaneously regardless of whether one failed. In version 6, this function no longer gets run on every single bar. It only gets run on bars where the close is higher than the previous bar's high, which means this function will start giving incorrect values on some bars. And if I bring up the compiler here and save my script, we have a warning. The ta.highest function call inside the conditional expression might not execute on every bar, which can cause inconsistent calculations because the function depends on historical results. For consistency, assign the call's result to a global variable and use that variable in the expression instead. What this means is, in order to get this code to execute consistently on every single bar, I need to take this function, create a new variable here called float highest bar equals, and then I can paste that in. And now what I need to check is, does the current bar's high equal this variable here? So I have extracted this function from this line of code, from this conditional statement, and it is now a global variable. This variable is initialized on every single bar on my chart, no matter what, every single tick that my script runs. And now we are checking the current bar's high value against that variable, no matter what. So if this check fails, it doesn't affect this function anymore. And this code here will just not be run. And that makes our scripts execute faster and more efficiently on the TradingView servers. So that's something to be aware of. It's a trap that you may fall into in your coding if you're not aware of this functionality of Pine Script. So again, this is a bit of an advanced concept. This went way over your head. Don't worry, just keep going on with the course. It's not something that will really impact you until you start developing complex scripts, but it is something I want to mention, especially for the more experienced coders out there, just to be aware of this functionality in Pine scripts so that you don't fall into this trap when you're developing more complex scripts. So in short, when you're working on a script, if you ever see a warning like this that says assign the call's result to a global variable, that's what this means. It means take that function out of your line of code and assign it to a global variable. And that's what this would look like. Hi traders, in this lesson I'm going to be showing you the fundamental concepts that you need to know regarding alerts in Pine script. So there are two ways to trigger alerts in Pine script. Both ways depend on Boolean triggers, so true or false triggers. If the trigger is true, an alert is fired. If it is false, no alert is triggered. So for today's example, we're going to keep it extremely simple. We'll cover practical alerts for things like setup detection, indicator conditions, that sort of thing in future lessons. For now, I'm just going to give you an overview of the basic functionality of alerts. So to do that, we're going to create a really simple alert condition. For this lesson, we're going to detect higher closes and lower closes. So HC is going to stand for higher close, and that's just going to check, does the current bar close higher than the previous bar's high? And then lower close is the same, but the opposite. Does the current bar close lower than the previous low? And this is the first time you're seeing the greater than and less than operators. In a future lesson, in the next section, we'll cover all of the different math operators and Pine script operators we have to work with. Don't worry about that for now. Basically, today we're just dealing with two Boolean variables, high close, lower close. If the current bar closes higher than the previous high, high close is set to true, otherwise it's set to false. And the same for lower close, but the opposite. It needs to close lower than the previous bar's low. And so now we have two different ways we can trigger alerts with these variables. The first way is to use the alert function. The second way is to use the alert condition function. And I'll go over the differences now. So first of all, let's use the alert function. The way this works is an alert function triggers an alert as soon as it is called. So, for example, if we check if HC is equal to true, fire our alert. And this alert function takes two parameters, message, which is a string, and frequency, which is an inbuilt variable, or built-in variable. So we have three options here, once per bar close, and both of these options basically. So if we set this to once per bar close, this alert will only fire if the current bar closes as a higher close bar. And the message can be anything. So we could make our string anything. I'm going to say here that this bar closed higher than previous bar. And then I'm going to add a colon on the end. And then I'm going to add on the current closing price of the bar to our alert. So to do that, we need to use the toString function because you cannot add a number directly to a string, and we need to use the str namespace here. We'll go over namespaces in a future lesson, but we need to say str.toString and then pass in our number, and this will convert the current closing price into text, into a string. And so when we get a higher close bar that closes, so our alert frequency is set to once per bar close. If we get a higher close bar, an alert will be fired with this text. So that's one way we can trigger alerts. It's quite simple, really. And now you don't need to specify these parameters here. The function will assume that the first parameter you give it is a string. So we could get rid of message equals. And it will also assume that the next parameter will be a alert frequency. So we can get rid of that. So we have our alert function triggering with a string argument and a frequency argument only on high close bars. Then we could do the same for if lower close. I could copy this string, paste it in there, change that to lower. And now we've got an alert firing on a lower close candle. And just to demonstrate that we can do it, let's change this to frequency once per bar. So this will not wait for the bar to be confirmed. It won't wait for the bar to close. So that's one way to fire alerts, and it's my preferred way to trigger alerts in my scripts. But there is also another option here, and that is the alert condition function. So this alert condition function cannot be placed in an if statement. It needs to be in your main script's scope. So it can't be in an if statement. It needs to be in your main script's sort of body of text. So it needs to be checked on every single bar on your chart. And this function takes 3 parameters instead of 2. The first is the condition, the Boolean condition to trigger the function. So in this case, if we wanted to trigger an alert for higher closes, we would pass in HC, comma. That's our condition. If HC is true, then the alert will fire. And then we have our title. So here I'm going to say higher close alert. And then we have our message. So for this, I'm just going to say the same thing here. This bar closed higher than the previous bar. Let's save the script and make sure that compiles. And there we go, no problems there. Now how this will work is on our real-time bar, on the current bar on our chart, this alert condition function will check is HC true? If it is, then fire an alert with the title, higher close alert, and the message, this bar closed higher than the previous bar. Now, there are a couple of differences between these functions. The first important one is that we cannot just add on our closing price as a string here, the same way we can with this alert function. If I save this script now, we will get an error. Cannot call alert condition with argument message equals, and then our series string. So a series string just means a string that can change based on certain conditions. So the closing price can obviously change at any time. The alert condition function does not accept any parameter that can change at any time. It needs a constant string, meaning a string that never changes, such as this right here. The only exception with this is that we can use placeholder tags. So if I come up to the alert button here and click on that, and I scroll down to the bottom here, you can see this text here. You can use special placeholders such as close, time, plot zero, etc. If you click on this little question mark button here, you can see all of the different placeholders we can use in our alerts. And there are quite a few of them. When we are using the alert condition function, the placeholder tags are the only way to put in variables that change. So for example, if we wanted to put in the closing price, we would need to do 2 curly brackets and then write close and then 2 close curly brackets. This placeholder would be replaced by TradingView when the alert fires with the current closing price. So now if I save the script and we come up to the alert button and I select our script alerts, if I click on this little drop down box here, you'll see that we have our any alert function call as an option. That is this function here. So we could set up an alert so that either of these get fired, or we can select our higher close alert, which is our alert condition. So if I click on that and I say once per bar and turn off my webhook. We'll cover webhooks in a future lesson. Don't worry about them for now. But if I just set an alert as this is right now, I've set it to once per bar. Because the current bar's price is greater than the previous bar's high, this alert should fire immediately. So let me click create. We'll wait for price action to move. As soon as price action moves, there we go, our alert is fired. So you can see when I hover over that alert, it says this bar closed higher than the previous bar, and then it has the closing price. So our little placeholder here was replaced with the closing price. You could also put in the ticker if you wanted to. So now if I save the script and set a new alert and select high close alert and click create, now we have a new alert that fired, and you can see that it now says the market, the ticker ID of the market that fired this alert. So that's how you pass in dynamic information into your alert condition functions. The alert function, on the other hand, is a lot easier to pass in information. So this particular function is definitely the preferred method for dealing with third-party APIs. For example, for trade automation using TradingView alerts, you would be better off using this alert function if you can. This alert condition, on the other hand, is great for manual alerts because you can give each alert a title. So for example, I could copy this, paste it down here, change this to lower close and change the condition to our lower close variable. Change that to lower. So here's our lower close alert. And then let's say we want to merge both of these. So we want to say if we have a higher close or we have a lower close, then we have a HCLC alert. And then we could just say this bar closed higher or lower than the previous bar. Now if I save the script and we come up to the alerts dialog and select our script, when I click on this drop-down box, we have 3 different alerts to choose from here. We have a high close, lower close alert, high close alert, and lower close alert with their own titles. So this is really useful for setting manual alerts in your scripts. Say you have a script that is designed to help traders trade your script manually and you want to detect things like a certain candlestick patterns or certain indicator conditions, that sort of thing. This is a great way to separate your alerts with a title to make it more intuitive for the user. Whereas this any alert function call will literally fire for any alert function call that we put in our script. Now, if I were to create this alert, nothing would happen because I've set my alert frequency to once per bar close. So we would have to wait for the bar to close higher than the previous bar for this to fire. Let me get rid of this close out of our alert frequency. So this should now fire immediately as soon as I set an alert on this any alert function call. So let me first click show pop-up and then click create. We'll see what happens. There we go. An alert just fired on euro dollar. It fired based on the any alert function call condition. And we get our text here that we wrote out here. So this bar closed higher than the previous bar, and then we have our bar price, our closing price. So for example, let's say we wanted to pass the current RSI value to our alert as well. We could replace this bar closed higher than the previous bar and then set the RSI value in there. So now it will tell us the current RSI value when we set our alert. So let me select alerts, leave that as it is, click create. There we have it. Now you can see our RSI value. Now there's a lot of decimal places here. I'll show you in a future lesson how you can truncate or cut excess decimal places off your alerts. But for now, that's not important. You can see the current RSI value over the 14 period is 68.62 or 63 if we round it up. And that's really all you need to know for alerts. We have these 2 methods for setting alerts. Both have their pros and cons. The pros for the alert function is that we can easily pass in values, so price values, indicator values, third-party syntax for sending your alerts to a service that automates your trades based on your alerts. If you're using a service like that, they will require a certain syntax for your alerts. So for example, you might need to say, set my stop loss to, and then in here you could set toString your stop loss price, and then you might need to put in a comma, take profit equals, and then put in your take profit price, etc. And then you could send this information to a third-party API using a webhook, using this. So for example, I've been using Pine Connector recently to automate some of my trading strategy scripts. If I send the right syntax in an alert message to this URL using the TradingView alert functionality, Pine Connector will automatically manage my trades for me based on the commands I give it in my alert message. And I can pass in my stop loss price, break-even distance, trailing stops, limit order entry prices, all that sort of thing, just using this technique that you see right here. So that'll do it for this particular lesson on alerts. This is the basic core functionality of alerts. We'll cover more detailed practical applications of this information in future lessons, especially when we get into setup, detection, and indicator conditions, that sort of thing. So I hope you found this lesson interesting, and I'll see you in the next one. Welcome to the user input lesson. In this lesson, we are going to be breaking down how we use user input to create settings menus for our scripts. So what you see in front of you right now is my ultimate pullback indicator script settings. This is the most complicated script I've ever written. It contains nearly 1,000 lines of code and has a lot of settings parameters that you can play around with. So this is what a complex settings menu might look like when you get proficient at Pine Script. You'll be able to create settings menus like this that are well organized, that have little tooltips that explain what each setting does, and you'll be able to group settings under titles like so. So in today's lesson, we're not going to create anything nearly as complex as this. We're just going to break down the core fundamentals of obtaining user input from the settings menu. So I'm going to remove this script and open up a blank script. Here we are. So all I've done here is change the plot to NA. So we're plotting nothing to the chart. All of our scripts require at least one plot function or one output function in order to compile. So I have this little plot function here, and I've added this script to my chart. And let's get started breaking down user inputs. Now, the first user input I'm going to introduce you to is the Boolean data type input. So get a Boolean input value. Now, if you're new to programming, don't freak out. A Boolean, it's a funny looking word, but all it means is true or false. So it's a data type that only holds a true or false value. So to get this input, I'm going to create a new variable here called input Boolean. And to get the input from the settings menu, we need to use the input dot, and then if you press Control space here or Command space on a Mac, you will get a list of all of the various user input data types we can choose from. Now don't worry, there's a few here, and I'll be breaking down each one of these in today's lesson, so don't feel overwhelmed. But the first one we're going to work with here is input.bool. So if I open up some parentheses here around our input.bool function, and if I hover my mouse over the bool keyword, we get a list of parameters that this function can take. So we have default value or def val, we have title, we have tooltip, we have inline, we have group, and we have confirm. I'll explain what each of these are one by one. Now, when I'm creating my user inputs, even though it says here that default value comes first, def val, I actually like to put the title first in my user inputs. So here I'm going to start with a title, and I'm going to title this input just on/off. So this is an on/off input. Then I will declare or define the default value. So for that, we just write def val equals, and let's set this one to true by default. Now that is the bare minimum we need in order to get a user input from our script settings menu. So if I click save here, minimize the editor, and click on this little cog icon of our script status bar, if I click on that, we now have a user input setting interface with just an on-off option here, a Boolean option. We could turn this on or off. It doesn't do anything at the moment, but obviously in future scripts, we'll be using these user inputs to inform the script how to behave. So that is the bare minimum we need in order to create a user input. In fact, you don't even need a title. You just need a default value. So if I save this and we open up the settings menu, we now have our Boolean input, and Pine Script is automatically assigning the name of the variable to the user input. So we called our input, our variable input Boolean, and so that is what our setting is called if we do not define a title ourselves. Now these other inputs we have are completely optional, but they are quite useful. So the first one I will show you here is tooltip. If I write out tooltip equals, this takes a string parameter, and this is literally just a tooltip that will appear next to your user input, and you can use these tooltips to explain what your user input does or to give instructions. So I could say here, turn on off this setting. Now if I save the script and open up my settings menu, we have this little I symbol here, and if I hover my mouse over that, we get the tooltip popping up. So you can have a tooltip on all of your settings if you want to, but it is an optional parameter. You don't need to put tooltips. If the setting is self-explanatory, like the title explains what the setting does, maybe you don't need to put a tooltip in. I like to put tooltips in all of my settings At least in my publicly published scripts, I like to include detailed instructions on how to use my scripts, but it is a completely optional feature. The next parameter we can work with is inline. So a good example of inline, how that works is, let me put my ultimate pullback indicator back on here. If I open up the settings menu, here is an example of an inline input. So we have several Boolean inputs here, and they are all on the same line, the same inline. That is what the inline parameter does. So if I say inline equals, let's just call it X. If I copy this and paste it 2 times, and we need to change our variable names here, so I'll just say 1 and 2. If I save this script and open up my settings menu, all of our inputs are now on the same line. Whereas if I get rid of these inline parameters and save the script, open up the settings menu, they are now all on their own lines. So the way this works is you need to input the same text for each inline that you want to be on that line. So we could have X, X, and Y here. Now if I save the script, 2 of our inputs will be on the same line, and then the third one will be on its own line. So that is how the inline parameter works. It's great for organizing your scripts. I love it with Boolean inputs, like what we have here. For example, on my ultimate pullback indicator, I have a section of the script that allows you to turn on or off certain days of the week. If I didn't use this inline feature, all of these would be on their own line, and my script settings menu is already long enough. So it's really helpful to be able to include simple options on the same line, especially ones that are in the same category. Anyway, let's get rid of these, and I'll get rid of the inline for now. And let's look at group. So group is what we use to create titled sections for our user inputs. So here I could say general settings, for example. And now if I save the script and open up the settings menu, our Boolean input is under its own title called general settings. And any user input that we create in our code that has the same group name here will be placed in the same group. So I can copy this again, paste it in a couple of times. If I save the script and open up my settings menu, all of these settings are under the same general settings group title. You can use inline with these as well. So I could have inline equals X. For example, save the script, and now we can use inline and groups in our user inputs as well. Now that is as creative as you can get with your user input organization. Obviously you can also do things like center your text using special symbols and things like that if you want to get really creative with your user inputs. But these are the only options we have in terms of organizing our interface. But for now, let me get rid of our groups and inlines and look at the final parameter we have to work with here, which is the confirm parameter. So the confirm parameter is a true or false value. By default, it's set to false and does nothing. But if you want to override that to true, you can do that. And now, if I save the script, this parameter only applies when you add the script to your chart for the first time. So now I need to remove the script. And if I click add to chart again, you'll see what this confirm parameter does. So let me click add to chart. Now we have a new dialog that's just popped up here that says confirm inputs. So now I need to confirm what I want this input to be before the script will be added to my chart. So if I click apply here, now the script is on my chart and we have confirmed this input. So this setting here is obviously very useful for certain settings in your scripts that are important to how the script functions. So for example, maybe you have a risk parameter in your script that dictates how much risk per trade one of your automated strategies sends to a third party to calculate your position size. That is an important parameter that you might want to add the confirm equals true flag to, so that whenever a user of your script adds it to the chart, they are forced to confirm that they have the correct settings inputted, and they're not just going with the default values. Obviously, this is an optional parameter for our user inputs, and so I can get rid of that there. Get rid of these other two booleans, save the script, and let's move on to some of the other data types. So what I've just showed you so far is the core fundamentals of the user input function. All of those parameters I just showed you, the tooltips, the groups, the inline, the confirm parameter, all of those can be used across all of our input functions and data types. So we won't go into too much detail about some of those as we work through this list, just to keep the lesson as short as possible. But we will cover the rest of these user inputs. So let's move on. The next input I'm going to demonstrate is how to get a color input from your users. So I'm going to call this input color and set this to input.color. And again, I like to set the title first in my user inputs, just because it makes it easier to edit. If you have a lot of user inputs, like my ultimate pullback indicator, it makes it easier to edit the code if you need to change the titles, if you keep them at the start of the input function instead of in the middle somewhere. You can organize these parameters any way you want to. There is no set order that you need to define these parameters in. I'm just teaching you my preferred method or coding process. So let's call this user input just color. And we will give it a default value of color.black. Now let's save the script, open up the settings menu, and here is our new input, color. And if we click on this color box here, we can select from all of the inbuilt colors that Pine Script offers. You can also adjust the style settings menu here. So you don't need to include color options in your main interface if you don't want to, but the option is there for those of you who maybe want your color setting to be easily accessible for certain plots or shapes in your script. So that's how we get color inputs. Very simple there. So the input color variable will now be treated as color.black by default, but the user can change that if they want to. Let's move on to the next user input I want to show you, which is integer inputs or whole number inputs. So here we're going to get an integer input value, and I'm going to call this variable input integer. And we need to use the input.int function in order to get an integer input. So I'm going to title this whole number, and we'll give it a default value of 5. Now the integer function here has a few extra parameters we can play around with. If you read down under syntax, you can see that we also have, in addition to everything we've just covered, we also have min_val or minimum value, max_val or maximum value, and step. So if we want to, we can hard code or define a minimum value for this input. All of these are optional. They're basically ignored by default, but if you have a input setting in your script that you want to make the user or force the user to stay within certain bounds, you can do that with the min_val and max_val parameters. So for this, I'm going to set the minimum value to -10 or -10, and I'll set the max_val to 10. And now if I save the script and open up the settings menu, we have our whole number input here. And if I click the little up arrow here, when we get to 10, it will not let me exceed 10. And same with -10. When we get down to -10, it will not let me exceed that. And if I put in a different number here, like 9999, as soon as I click off this, it will be cut down to 9. If I put in 100,000, it's cut down to 10. So that is how you use minimum val and maximum val. You can also use step. Now step is used to tell the interface how to step your value up or down when you click on those arrows. So if I set our step to 5, save our code, open up the settings menu. Now when I click on this down arrow, the number will change from 10 to 5 to 0, -5, -10. So the value is changing in steps of 5. Now, it's not often you will use these parameters, but they are pretty handy under certain circumstances. For example, if you're working with a risk-reward multiplier, like my ultimate pullback indicator does, I've set the step on this to 0.1. So whenever you click on the up arrow or down arrow, your risk-reward profile changes by 0.1. So if I left this with the default 1 step, then every time you click the up arrow or down arrow, your risk-reward would change by a full number, which doesn't give you as much minute control over these settings. Obviously, you could just type in 1.1 into the text box here, but depending on how professional you want to make your script, especially if you're publicly publishing it, especially if it's a premium paid script like my ultimate pullback indicator is, then you want to go that extra mile and make sure that all of your settings are intuitive and easy to use. The step parameter and the min val and max val parameters can help with that. Anyway, moving on, we could also use the group and inline and tooltip parameters on this user input, but we'll skip that for now since it's the same for all inputs and we've already covered that. You'll notice here that we have two versions of input.integer as a user input function. The top one has the min val, max val, step, and all of that. The second one has no min val, no max val, no step, but has an options parameter. So you can't use min val, max val, and step with your options parameter, but you can define options that you want your user to select from. So to define a list of options in your settings menu, you need to specify the parameter options equals, and then we use these square brackets to define a list of options. And here I could write 1, 2, 3, 4, 5. Let's save the script and open up our settings menu. Now, instead of allowing us to type in a value in this user input, we have a drop-down box here with all of the options that we just specified. So this is a cool way to limit your user input to a set list of options, which is useful under certain circumstances. Again, if I open up my ultimate pullback indicator, I use these little drop-down boxes quite a bit in my script. So a great example of this drop-down list is my MA type, moving average type setting. Under this setting, you can select from all of these different moving average types, and the script will change how it calculates the moving average based on what you select here. And that is achieved using the options parameter. We'll get to how to use this parameter with strings later on in this lesson, which is what I did here. This is a string options list, but that is how you use options in your integer inputs. The format is the same for any other data type that allows you to choose options. Now, color doesn't allow you, Boolean doesn't allow you, but integers, floats, strings, all of those will allow you to specify a predetermined list of options that your script user can select from. Anyway, moving on, let's get a float input value, so a decimal number. So I'm going to call this variable input float, and that's going to be set to input.float. And now we have exactly the same options we had with the integer input. We have min val, max val, step, and the options version of this input function. So let me title this decimal number. We'll give it a default value of minus 0.5. Let's go with a negative number this time. And we'll give it a minimum value of negative 3.14 and a max val of positive 3.14. And let's give it a step of 0.01. Let me save this script and open up my settings menu. And here is our new float input. And it will change in steps of 0.01, and it has a maximum value of 3.14, so it won't go beyond that, and it won't go beyond minus 3.14. So if I try to do minus 3.15, it keeps changing back to whatever it was before. And obviously we could also use a list of options here. It's exactly the same syntax to specify a list of options for our input, float inputs. So I won't go over that. Once you learn the fundamentals of getting user input, this is all quite simple and intuitive. All of these parameters are the same across all the data types. There are obviously just a few nuances in how these inputs work. So that is our float inputs. Let's try getting a symbol input value. So this is a market symbol. I'm going to call this variable input symbol, and we'll use the input.symbol function. If I hover my mouse over symbol, we can see the options we have for the function parameters we have to work with here. We don't have many. We just have default value, title, tooltip, inline, group, and confirm. So I'm going to title this just symbol, and we'll give it a default value of SPY. So we'll load up the S&P 500 SPY index by default. So let's save the script and open up our settings menu. And here is our symbol input. You'll notice it looks quite different to all of our other ones. That's because if we click on this, it opens up the symbol dialog box. So we could choose from any market symbol here. It will only allow valid symbols into this input. So as opposed to a string input where you can put any string you want, the symbol input will only allow you to choose from real symbols. So if we wanted to load Bitcoin, for example, let's go Bitcoin USD from Coinbase, click on that. Now, if we were to reference this variable in our script, for example, let's say we wanted to get the current price of whatever market the user selects here, we could pass this variable into the function that retrieves that market's price, the security function, which we'll cover later in the course. And we can be certain that whatever the user selects here will be a real symbol. And that is the purpose of the symbol input. Anyway, let's move on to the next input, which is going to be a price input. So I'm going to say here, get a price input. Input price is set to input.price. So the price user input is similar to the symbol input in that we don't have a lot of options here. We can set the title. So I'll set the title to price. I'll set the default value to, let's just go 0.0. And now if I were to save the script and open the settings menu, we would have a number input here that we could play around with. But one of the cool things about this input and what makes it different to a float input is that we can use the confirm parameter here. If we set confirm to true and I remove the script from my chart, save my code, and I add the script back to my chart, let me get rid of my ultimate pullback indicator. Now you can see this horizontal line that is following my mouse. This is our price input. So because I set confirm to true on this input, when we add this script to our chart, TradingView is forcing the user to select the price. And whatever price we select here will be automatically applied to that input. So if I click up here at 1.161-ish and open up my settings menu, here is our price input. So that's a cool user input there. Very useful for certain styles of indicators. For example, maybe you want to see how many times price action crossed a certain price. You could use this parameter to have the user just simply click somewhere on their chart, and maybe your script can analyze price action around that price to try and find information about that specific price. For example, you could get how much volume was traded at that price or something like that. So pretty cool new input there. That is brand new to Pine Script as of recording this. This feature didn't exist a few weeks ago, but we can now use price inputs to visually select that input if we want to. You could also use a float input if you don't want to have the user select the price, or just get rid of confirm. But the option is there. So let me save the script there and we will move on. Let's have a look at another input we can work with, which is going to be our source input. So we're going to get a source input value. I will create, let me make some space here. I'll create a new variable called input source, and this will be set to input dot, you guessed it, source. And if I hover my mouse over the source function here, we get a list of parameters we can work with. We have default value, title, tooltip, inline, and group. So I'm going to title this input source, and I'm going to give it a default value of, and now this is a price source. So there are a few we can choose from. A classic example would be the closing price. So if I save the script here and open up the settings menu, this source input here allows us to select from the open, high, low, close, and then we can get the average between the high and low, or we can get the average between the high, low, and close, or the average between the entire candle size. And so this is a great way to allow users of your script to change the price source of certain indicator values that your script uses. For example, maybe you want to change the price source of the RSI indicator in your script, or a moving average, and you get the idea. There's a lot of ways we could use this. So that's the price source input. Let's move on to the next input, which is going to be time and date input. So this input will get us a specific time and date. So input.time is the function. If I hover my mouse there, again, we don't have any extra options to work with here. We just have a title. So I'll call this time, and I'll give it a default value of, and now this time input can take a timestamp value as its default value. So actually I don't need the quotation marks here. I can use the timestamp function, the inbuilt timestamp function in Pine Script, to get the time value of a certain time of year and time of day, certain time zone, all of that. So for example, if I want to get the 1st of January 2000 at 1:30 p.m. in the time zone of 0 GMT, I can write it out like this. If I close that off and save the script, now if I open up the settings menu, we have our time input here with a user interface dialog where we can select the date. My screen resolution's really turned up for this lesson, so it's not fitting on the screen. But you can see here we can select any date we want and any time of day that we want. So this is a really useful user input for things like time and date filters. So in a lot of my scripts, I have a time filter that I can specify when to take trades between. So I could specify a date to start taking trades and a date to stop taking trades. And I can use that information to analyze price action between a certain date. For example, maybe I want to see how my strategy performed during the 2008 financial crisis. I could set this first date to 2006 or 2007, and my end date to 2009 or 2010, and see how my strategy performed during that specific time period. So that is what this user input is useful for. Just while we're here, I'm going to also throw on the group, we'll call this time settings. There are a few time inputs we can work with, so I'm going to group all of these together under time settings. And one other thing we can do with time, which is cool, is we can set the confirm parameter to true. And this, the same way price allowed us to select a price, this will allow us to select a time and date. So if I remove the script from my chart, save the code, bring this down a bit and add this back to my chart, now you can see this little tooltip pops up. Set the time for this script. So this vertical line now is on my mouse, and I can select any time, any bar on my chart here, and that will change the time setting to whatever I selected. So that is a cool new feature of Pine Script version 5. But let me get rid of that for now, because it's going to be annoying if I need to add the script back to my chart. And that's it for our time inputs. Let's move on here to our next input, which is going to be input resolution. So I'm going to say get a resolution input value, and I'll call this variable input resolution. And this will be set to input dot. And now this time we need to select time frame. And this is a actual time frame on your chart. So for example, for a 1 hour chart, you would put in 60, and that will give you the 60-minute time frame. If you want a daily, you can put in D or 1440. There are 1440 minutes in a day. So let's title this time frame, and we'll give it a default value of 60. And we'll also give it a group of time settings. And actually, while we're doing this, this is a good place to show you how we can use variables to assign our group names. So for example, here we could say get time inputs, and let's declare a new VAR variable, a persistent variable that never changes. We will never change this variable's value in our script, and we'll call it capital G underscore time. And this is going to be a string variable. And this is going to be our group title for our time settings. So G stands for group, and we're going to put in here time settings. And now I can copy this variable and paste it into our group parameter here. And now if I save the script and open up my settings, we have our time settings title here. And if we wanted to change this, all we need to do is change this once. We just change this variable string here, and that will change all of our group titles. So that's a good practice to get into if you're working with lots of user inputs and you want to group them all together, but make it easy to rename groups later if you need to. Now, the reason I used the var keyword or VAR keyword and made this a persistent variable is because this value will never change in our script. So we only need to declare it once. So when our script runs on the very first bar of our chart, this variable will be created and it will never change. We'll never change it in our script. So we don't need to. We could get rid of VAR variable and the script will still work just fine. But I think it's good practice to do this sort of thing when dealing with variables that never change. This way, Pine Script only has to create this variable once instead of recreating it on every new bar in our chart. So that's why I did it this way. But anyway, let's move on. So if I open up my settings menu, we now have our time frame user input, and we can click on this little drop down box and select from all of these time frames. So for example, if I set this to D and save my code and open up my settings menu, this is now set to 1 day. Now, if you want to set your time frame or resolution input to a number that is not listed here, to a time frame that is not listed here, you'll need to use a string input in order to get the value, the time frame value. So that's a good place as any to show you how to get string inputs. So here we'll say get a string input. So for this, I'm going to create a new variable called input string, and this will be set to input.the string function. If I hover over this function name, we have a bunch of options here. We have our title, so I'm going to call this string. We have a default value. So let's set this to, let's say, just A for now. And if I save the script and open up my settings, we now have a new string input down here. And I can type anything I want into this. So for example, you could use this to specify a time frame that is not in this list. So let's say we wanted to work with a 10-minute time frame. You could change this to time frame, the name of this input, and you could put 10 in there. And then when you pass your time frame into your script code later on, you could just use that user input to specify any time frame that the user wants to work with. But for today's example, we'll stick with this A default string, and I'll show you how to create a list of options that we can use with strings. So here I'm going to create a list of strings. We're going to have A, B, and C, and we'll also throw a tooltip in here. We'll say select an option, save the script, open up our settings, and now instead of being able to click on this string input and type in whatever we want, we have a list of options to choose from. So A, B, and C. And if we hover over our tooltip, that will be able to contain instructions on what each option here does. And as I showed you earlier in this lesson, this is extremely useful for all kinds of applications. One of my favorites is to use this to allow the user to select what moving average type they want to use in the script. Anyway, that's it for our string inputs. Let me move this. Actually, we'll move this above our time inputs because there is one more time input that I want to show you before we wrap up this lesson. And that is a session input value. So let me create a new variable here called input session, and this will be set to input.session. And now this function has a few options here. Similar to the string input function, we have title we can work with. So I'll call this one session. We have default value. So this is a time session. This is a session between 2 times of day. So for example, I could set this to 0300, that would be 3 a.m. and 1300, which would be 1 p.m. And let's also group this into our g_time group, our time settings group. Now you'll notice if I hover over that function, we can also add options to this. So we could have a list of time sessions to choose from if the user wants to. I'm going to leave this as it is for now so that the user can come down here and select the start hour and end hour of this session. So this particular user input is really useful for things like time filters. So here in Australia, when I'm trading the Forex markets, in the early hours here, between around 6 a.m. to 8 a.m., the Forex markets are extremely quiet and my spread gets a bit crazy. So my cost to trade is quite high. If I use a market order to enter or exit a trade during that time session, I can be hit with a massive spread, huge slippage on my trades. And so I like to include time session filters in some of my strategies to exclude certain times of day so that my script will not trade or analyze price, generate alerts, etc. during that time of day. And one other use case for this obviously is the opposite. Maybe you only want your script to trade during a certain time of day. A good example of that is my follow the bear strategy. Here it is now. This strategy only trades during a certain time of day. So you can see on the back of my chart here, I have these red zones. That is a particular time session. For me, it's between 4 p.m. and 8 p.m. During that time session, there is a certain candlestick pattern that unfolds on euro dollar that is quite profitable to trade. And so I use the time session input parameter so that the user can select the time session they want to trade. Now it says 2 a.m. to 7 a.m. here. That's because these time session inputs are based on the exchange that your market data is coming from. So even though when I hover over this bar, it says 4 p.m. down there, it's actually 2 a.m. on my broker's exchange time zone. So that's important to keep in mind when working with time session inputs. Anyway, that about sums it up for our user input setting. This is all a bit messy. We could significantly tidy up this script by using our group parameters and inline parameters and all of that if we wanted to. But because this is just introducing you to these concepts, I'll leave it here. In future lessons, we'll definitely be using a lot more of the group and inline and tooltip parameters when we start dealing with practical use cases for this information. But for now, that will do it for today's lesson. I'll leave the source code to this script underneath this video for you to have a look at and play around with if you want to. And I will see you in the next lesson. Take care, best of luck with your trading in the meantime, and I'll speak with you soon. Hey traders, let's go over how to draw stuff onto your chart. This is the funnest thing about Pine Script, being able to visualize what you are analyzing. To do that, we have several functions to work with. The most common function we will be using is plot. Plot draws a line onto our chart. So for example, the most basic thing we can plot is the number 1. Let's save my code here. And here you can see we are plotting the number 1 on every bar on my chart as just a solid line. If I change this to close, then we will be plotting the closing price value of every bar on my chart. We essentially get a line graph there, or a line chart. So let's leave this as close for now, and let's go over all of the parameters we have to work with here. So the first one is the title. Now for each parameter, you can explicitly say what the parameter is, like this. This is a title, save my code. And now this doesn't actually draw anything onto my chart, but if we open up the data window over here, go to data window, you can see here, this is my script, and we have the title of the plot there and the value next to it. So this is mostly for debugging, but it's a good idea to title your plots anyway, even if you don't use this, just so that you know what this is. So I could say here closing price. And at least now, just glancing at my script, if this wasn't a closing price and it was some sort of equation, having a title here will help me and anyone who reads my code to know exactly what this is drawing. Now, because title is the second parameter in the plot, if I hover over this, you can see it says series and then title. Series is just a series of data. So in this case, we're plotting the series of closing values. Because the next required parameter or expected parameter is a title, I don't need to explicitly say title here. I can just have the title straight in just like that, and that will work just the same. So that's fine. Let's move on to another parameter. Let's say I wanted to specify the drawing style of my plot now, and I didn't want to specify the line width. Because I'm skipping a parameter here and we're not providing parameters in order as they appear, I would need to explicitly say what my parameter is here. Because this function is expecting a line width next, I need to tell it, I'm not giving you a line width, I'm giving you a style now. So I didn't have to specify series here, and I didn't have to specify title here, although that would work just the same. And then we're plotting an area onto my chart using the closing price value. If I get rid of these and get rid of this one, we will get a compiler error because Pine Script was expecting a color there. If I hover over this, you can see it says series, title, color, line width, style. I skipped 2 parameters here and it was expecting a color. But if I explicitly tell Pine Script this value here is a style parameter, then I don't need to provide those other parameters, and just the default value will be used for any parameter that's not specified. The default value will be used. So let's go over each parameter. The next one is color. So that's self-explanatory. If you type in color dot control space, you have a bunch of inbuilt colors to work with. Let's pick a fun color. Let's go with lime. Save my code. You can see here a little color panel or widget appears to show me what that color will look like on my chart, and you can actually hover over that and pick a color with your mouse here. So if you hover over that, don't click it, just hover and then pull this to where you want it, and you can drag this around here, pick a color, and then click on here to convert the color to whatever you clicked on. So this parameter accepts a hex code for those HTML and CSS programmers out there. This is the way web browsers interpret colors. So we can literally just click on any color we want here. Let's stick with that color. Click on that. Now I can either have this as a hex code or a red, green, blue value. This is my preferred way of working with colors because it's more intuitive for me to visually read. Having a value of 0 means no red, no green, or no blue. Having a value of 255 means full red, full green, or full blue. So if I change the B value here to 0, that would give me fluoro green. So if I change that to a 0 and save my script, we get a bright green line there. So color.rgb gives us 3 values to work with: red, green, blue. And there's an optional parameter here for transparency. So if I set this to 50, that would be 50% transparent. And my line will be a bit faded there because it's actually transparent, and anything that was drawing underneath it would be visible through this plot. But let's change this back to color.lime for now and move on to the next parameter, which is line width. This is pretty self-explanatory. The default value is 1. It is not applicable to every style, so every plot style, which is the next parameter. But for now, since the default value is 1, let's try 2. See how that changes the plot. You can see it's a little bit thicker, and the higher the line thickness or line width, the thicker our plot will be, as you can see there. The default value is 1. Moving on, we have style. So if I type here style and then scroll down to plot, these are the different styles of plots we have to work with. I won't go over all of these because there's quite a few. By default, we're working with plot style line. If I change it to histogram, we'll get like columns, like you can see there, kind of like a MACD kind of style. If I change it to area, we'll get an area, and so on. You get the idea. There's some pretty cool styles we have to work with here, and obviously, depending on what script you're working on, you might prefer one of these styles over another. So step line, if I save my code and I zoom in, we get steps between each line instead of having the smoothing of a regular line. I'll change this back to area for now. Let's have a look at the next parameter, which is track price. By default, this is turned off. If I change this to true and save my code, we will now get a horizontal line that is tracking the current value of price on my chart. So as price moves, so will this line. And if I come over to my price scale here and I right click and come down to labels, I can turn on or off indicators in financials value labels. And now I can actually see that indicator value on my chart. Now this doesn't need to be a price value. I already have the price value showing up there. So let's change my plot from close to volume. Save my code. Now we're drawing volume as an area, and I can actually see the volume plotting on my scale here. So remember, if you forget what each parameter is, you can specify it explicitly by typing the parameter name there, but I'll leave that off for now. And let's move on to the next one, which is hist base. This is the price value used as the reference level when rendering a plot with a histogram. So let's change this back to histogram. Style underscore histogram. We'll leave track price on, and we'll change this value to, let's say for some reason we wanted the midpoint of our histogram to be 500. So I'll change that to 500 and save my code. You can now see that anything above 500 is a positive bar, and anything below is a negative bar or a downwards bar. And the midpoint is about 500. Now this is a useless example, but there's obviously times when you would want this. This is how the MACD works with its positive and negative histograms. The midpoint is 0, and anything above or below 0 gets drawn like this. So that's hist base. Offset, if I change this back to close and we change this back to line, offset is how many bars to draw back to the left. So actually I'll leave this as histogram. And I'll change offset to, let's change it to 50 so that it's really obvious what this is doing. If I rescale my chart and we zoom in here, you can see that the latest bar here is drawing 50 bars to the right. So we have offset from the current bar 50 bars to the right. And if this was drawing over price action, if I change this to overlay equals true, save my code and re-add this back to my chart. Now we're drawing a delayed histogram of price. So you can see this peak here is offset 50 bars to the right using the offset function. If I wanted to shift it back to the left, we would use a negative number. So negative 50 will now shift our drawings 50 bars to the left. There are certain times when you would use this function. For example, the Ichimoku cloud uses this feature, but most plots won't. So we'll leave that as 0 for now and we'll move on. Join. If this is set to true, join equals true, then all plot points will be joined with a line. And this is applicable only to style cross and style circle. So let's change this back to, let's change it to style cross. As a closing price, this will plot the closing price. And actually, let me move this back into its own panel. There we go. If I zoom in here, it's a bit hard to see, but we actually have, because of my screen resolution, it's really hard to see, but we have crosses drawing here and a line connecting them all. If I change this back to false, which it is by default, then we are only going to have crosses. As you can see there, we've got these dot crosses. So if you wanted to join these plots, you would set join to true. So I'll leave it as false for now, and we'll move on to the next parameter, which is editable. So editable is on by default. So if I set editable equals true, save my code, what this does is allow the user to come up to the settings here, come to style, and edit the color and the plot style of that plot. But if for some reason you don't want the user to do that, and generally you would, I don't really know why you'd turn this to false, but there may be reasons to avoid confusion with a particular plot. You may want to set this to false, and now when I save my code and it updates, people can't change the style of that plot anymore. You can see these settings have disappeared completely for that plot. So that is how you turn off editability. Show last dictates the number of bars from the current bar back into the past to plot onto our chart. So if I change this to 10 bars and I change this back to line, we save my code, we will now only be drawing the last 10 bars of price action because show last is set to 10. If I count back 10 bars, remember the current bar is bar 0, so 0 to 9 is 10 bars. Normally you won't want to specify this, but I'll set this to 100 for now, so we'll draw over the past 100 bars. We'll move on to the next parameter, which is display. This is a very important parameter. This allows us to tell Pine Script how we want to display our plot. So by default, it's going to be set to display.all. So if I save my code, this will draw up here. It will draw onto my chart. It will draw into the data window here, and we can see it everywhere. Now let's say, for example, I wanted to plot some information that my script is doing, but I don't want to see it. I don't want the user to see it. I just want to be able to see it as a developer. This is for debugging. I'm just curious to see what a certain value is. It's not relevant to the person using the script. It's purely for me as a coder. I could change this to display_data window, save my code, and now this plot will disappear off my chart. It no longer displays here. It no longer displays here. It only displays in the data window. So now when I hover my mouse over a bar, I can see what the value for that bar is, and it will only display here. So this is great for reducing clutter on your script, visual clutter, when you still need to plot something. Sometimes you won't want to plot a value onto your actual screen like this, but you still want to see it on the indicator value without having to open the data window. So a good example of this might be the ATR. Maybe you want to see the average true range, but you don't care to see it plotted onto the chart. It's not important. It's just for you to be able to visually see what the current ATR is on the current bar, maybe for stop loss placement or something like that. If I change this to TA ATR 14 period ATR, and I change this to status line, save my code. Now we will be plotting the current ATR value onto my status line, but it's not drawing onto my scale here. So maybe I have other things drawing here, and now I know this is the ATR. It says closing price there because of my title. I change this to ATR. Now we can see that that's the current ATR value. Some other options we have here is pane. So this is the opposite. Let's say I only want to see the ATR on my chart, but I don't want to see it here, and I don't want to see it in the data window. I can change this to pane, and this will draw onto the window pane. So now if I save my code, now we have the ATR drawing, but we don't have a label. It's not in our data window, and it's not in our status bar. It's only drawing onto the chart. So it's not often that you would need this, but the option is there if you do. We also have price scale. So let's say we want to plot the closing price. I'll just change this to my plot, save my code. Now the value will only draw. I need to shrink this down a bit. In fact, let's reset the chart view. Now I'm drawing the closing price of the current market without anything in my status bar, anything on my chart, or anything in my data window. So this is reducing clutter. Again, it's not often you would use that feature, but it's there if you need it. So those are the main options. And you also have displayed on none. So for example, I have a script where I have a version number, and I use this for users of my script to know what version of my script they're using. So I could say plot NA version 3.19. If I set display equals display.none and save my code, now it doesn't draw here, it doesn't draw in the data window, it doesn't draw anywhere. But if I come up to the settings and open this, you can see that the plot is in my style settings, and so I can see the version number without it cluttering up anywhere on my chart. So that's one use case for display.none. For now, let's leave this as display.all and move on to the next parameter, which is format. Format determines whether the script formats this plot's value as prices, percentages, or volume values. So I'll show you exactly what this does. If we change this to volume, and I change format equals format.price, save my code. Now we are plotting the volume as a price value. So this is showing the Bitcoin volume in terms of Bitcoin as we would format price. So 2 decimal places after the quote price. That's the number we get here. So on this bar here, we had 1,327.02 Bitcoin traded. If I change this to volume, you'll see that we now have on that same bar 1.02K. Now for Bitcoin, it's not a big deal, but if we go to something like SPY, change this to SPY, you can see that now says 36 million contracts traded. If I change this back to price, you're going to see why this format option exists. You can see now it's showing the exact number of contracts traded, which is obviously a very large number. And we don't really need to know that when we're dealing with a volume reading. An abbreviated version of that is just fine when we're dealing with volume, especially for a large liquid instrument like this. So if I change that back to volume, you can now see these values change to 34 million and it's rounded to the nearest value. Percentage is self-explanatory. Percent will display this as a percentage. So you can see there. So it's up to you to make sure you're plotting the correct value corresponding to the format here. So if this value here was let's change this to ta.roc on the close over the past 10 bars. Now you can see this is plotted as a percentage, and that's exactly what we want. If I didn't do that, if I got rid of this, then that would be plotting as a regular decimal value. You can see the percentage sign has disappeared off there. So that's what the format parameter is for. We have a couple left. We have precision. This is decimal precision. So if I change this to 5 and leave this as ROC, rate of change, and save my code, we'll now get that percentage value with 5 decimal places. So depending on what you're working with, you may need more decimal places to get an accurate reading. That's what the precision parameter is for. The final parameter, as of November 2024, sometimes they add new parameters, but for now, this is all the parameters we have to work with, and that is force overlay. So this is a really good parameter as well. They save the best for last. Let's say we wanted to draw the RSI value. So we'll change this to RSI and get rid of all of these parameters here. Save my code. So now we're getting the current RSI value. Let's say that every time price exceeds 70, I want to draw an arrow on my price action. So I want the RSI value drawing down here, and I want something to draw on my chart as well. What I could do here is say plot shape ta.rsi close 14/70 (1), otherwise NA. You don't need to know what this code is doing. We'll cover this later on in the course, this sort of advanced code. But basically, this is only going to draw a shape if the RSI is over 70. Otherwise, it's going to draw nothing or no value. If I save my code as is, you can see we're now getting these X's, these blue X's drawing whenever the RSI value goes over 70. But I want this drawing over my price bars. So what I can do is set force overlay equals true, save my code, and now those crosses have jumped out of there up onto my price action. And for every bar that is printed over 70 RSI, we're getting these crosses. That's what the force overlay true parameter does. Obviously, it's false by default. Now we cannot do the other way around. If I were to set overlay here to true and remove this from my chart, save it and add it back on, now we're getting the RSI value drawing over price action and the plot shapes drawing over price action. And this is now redundant because I've added this script, this setting here to true, overlay equals true. Everything my script does now draws over price action. So this is a one-way street. When I'm working with an oscillator like the RSI or MACD or any other oscillator, I would want this to be false, which it is by default. So I can get rid of that, remove this from my chart, save it, add it to my chart. And then for anything I want drawing over price action, I need to set force overlay equals true. So that's it for the plot function. A lot to cover there. Hey traders, welcome to the fill function lesson. In this lesson, I'm going to show you how you can use the fill function to fill between two values on your chart with a certain color. So it's really quite easy. For this particular demonstration, I'm going to just plot the high, and I'm going to assign this plot to a variable. So you can actually assign plots to variables and then reference those variables in other functions, like the fill function. So we're going to assign H to plot the high and L to plot the low. And then we are going to use the fill function to fill a color between these two values. So before we do that, let's save the script and see the two plots on our chart. There they are. I'll zoom in a bit here. Now let's fill between these two plots. So the fill function takes a whole bunch of parameters. There are two different versions of the fill function. One takes plots as its reference point to fill between. The other one takes horizontal lines. But the two functions behave very similarly. We'll go over the plots first. So to fill between two plots, we just need to pass in our two plot variables, so H and L. And then we need to specify a color. So I'm going to set this to color.red. And that's it. If I save the script, we will now be filling these two plots with the color red, like you see there. And as I showed in the previous lesson, if you want to use transparency, you can use the color.new, color.red, comma, and then specify your transparency. So if we wanted this to be, let's say 25% transparent, we would put in 25, close off that parentheses, and then close off the fill function parentheses, and then save the script. And it's hard to see there, but the transparency did drop. If we set this to 90, then we'll be 90% transparent and we'll barely be able to see the red color. There we go. Let's set this back to 25. And let's move on to some of these other parameters. So the next one is title. This parameter applies to all of the drawing functions in Pine Script. We could call this whatever we want. We'll call this one fillet of fish. Why not? Click save. And when we open up the settings menu, there's our fillet of fish. And you can obviously adjust this however you want to. The user of your script can change the color, transparency, or turn it off if they want to. The next parameter is editable, which is the same on all of these drawing functions. This just turns on or off the editability of your plot. So if by default, it's obviously set to true because we can edit it here. But if we set this to false, save the script, then now when we open this up, there is no fillet of fish. Very disappointing. Don't know why you would want to deny the users of your script the ability to edit your fillet of fish, but if you're a party pooper like that, you can do that in your script using the editable parameter. So the next parameter that we can work with our fill function is fill gaps. So before we use this, let's create a gap in our plots. To do that, I'm going to hard code a little conditional statement in here. This is a little bit advanced. We'll cover this stuff in a future chapter of the course. So don't feel overwhelmed when you see this code. If you're new to programming, this might scare you a little bit, but don't worry, I'll explain exactly how this works in a future lesson. This is just to demonstrate what gaps look like when you're plotting onto your chart. So for this, I'm going to say, is the high greater than 116? Question mark. If so, plot the high, otherwise plot nothing. Now again, don't worry if this looks confusing to you. It's not important for this lesson. All we want to do here is generate some gaps in our plots. So let me save this script. Now you can see that our lines have become some sort of abstract art project. And I need to change this to the low. And now if I save the script, there we go. Now it might be easier for you to see what's going on here if I change the style of our plot, like I showed in the previous lesson on the plot function. We covered a few of these styles. One of the styles we didn't cover is style line break. So if I copy that down here and save the script, you can now see that there's gaps, there's breaks between some of our plots. That's because of the style we've selected here. And notice that our fill function does not fill between these gaps. Well, we can change that with the fill gaps parameter. If I set this to true and save the script, these gaps will now be filled by the fill function. Now the final parameter I haven't covered yet is the show last parameter. Now this does the same thing as it does in the plot lesson. If I set show underscore last to 10, for example, and we get rid of all of this and reset my chart, the fill function is now only filling the last 10 bars on our chart. So that's it for the plot version of the fill function. When we use the fill function to fill between two plot variables, those are all the parameters we have to work with. Now I'll show you how to use the horizontal line version of this fill function. So under syntax down here, you'll see that we have two fill functions, one with H lines, one with plots. To use H lines, it's quite easy. all we do is use the hline function, and then we pass in a value. So for this example, I'm going to pass in 1.16, and for the bottom hline, I'm going to pass in 1.155. And for this, let's set the color to color.green. And now let's save the script. And now we have an error here. I forgot that we need to include at least one output function call, like a plot, bar color, etc. We need to draw something onto the actual chart. So to do that, I'm just going to plot NA, which will just draw nothing onto our chart. If I save the script, there we go. Now it works fine. If I shrink this box down a little bit, you can see our two horizontal lines here at 116 and 155. And we're filling between those two horizontal lines. Now I won't go over all of the parameters for this fill function because they're identical to the previous one. The only difference with this one is that we do not have access to the show last parameter. So we can't use the show last parameter to limit how many bars this fill function draws over when working with horizontal lines. Anyway, there we have it. That's the fill function. Those are the parameters we have to work with. And that is the end of this lesson. I'll see you in the next one. Hello, welcome back my friends to another lesson. In this lesson we are going to be exploring colors in Pine Script. So we have several ways to work with colors in our scripts. The most common colors you'll probably use are the inbuilt colors. So right here I have pretty much a blank script. All I've done is change the plot function to a background color function. I've created a variable called myTotalAwesomeColor, and I've set this variable to color.black. And then I'm just passing this variable into our background color function. As such, we are getting a black background plotting into our indicator box here. So the first colors I want to cover are the inbuilt ones. If we press Control Space after writing color and a full stop, we get all of the color namespace functions and variables. They're all mixed in here. We'll go over the RGB functions and all of these other functions here in a moment, but what I want to draw your attention to are these colors here. These are all built-in colors that you can quickly and easily reference in your scripts. So if we wanted to set this to aqua, if I save the script, voila, we have an aqua background color. So that is the easiest way to use color in Pine Script. We do have a few other options here though. The next option I want to show you is the RGB function. So this function takes up to 4 parameters. It requires a minimum of 3. You need to specify the red amount, the green amount, and the blue amount. If you remember primary school, the primary color tables, a mix of these colors will give you different colors. And these values range from 0 to 255. Now don't ask me why it's not 0 to 100. It's complex to explain. It has something to do with how many bits, like computer bits, are involved in the number that generates the color. You don't need to know any of that stuff. All you need to know is that 100% red is 255, 0% red is 0. So if I wanted to get just the color red, I would type in here 255, 0, 0. Now when I save the script, we'll get a red, bright red background onto our indicator box. So the first number is our red value, the second is our green value, RG, and then B is blue. That's our final value here. We can also optionally, this is not mandatory, but you can choose to specify a transparency amount. So if I put 50 in here, when I save this script, our color will have a 50% transparency applied to it, and it will be a little bit dimmer as you see there. So that's all you really need to know about the RGB function. If you want to get a mix of red, green, and blue to generate a custom color, you can use various free tools online. Just Google RGB generator or RGB colors, and there's plenty of tools out here. Color Picker is a good one, where you can pick your color and you get your RGB value as well as hexadecimal colors, which we'll cover in a moment. But first, let's get back to the Pine editor. So that is how you build a color using the RGB function. We could change these values if we want to. Let's change them to just random numbers and save the script. Now we're getting a random color. So that's how you can play around with the RGB function to get custom colors. There are some other color functions we have to work with. If I do color.control space, we can get the individual colors from a color, so we can get the blue value, the green value, and the red value if we want to. I don't think you'll ever need to do this unless you're working with a script that has a complex color theme to it. So we'll skip that for now. So let's move on to another common application of the color namespace that you will be using, which is to generate transparency on the inbuilt colors. So let's say we just want to use color dot, let's go with blue this time. If I save the script, now we have a bright blue as our background color. But what if I wanted to apply, let's say 20% transparency to this color? Well, the way we do that is using the color.new function. So this will generate a new color from an existing color, and basically it will just apply the transparency to the given color. So if I pass in here color.blue, comma, and then the next number we put in here will dictate the transparency of this new color. So if I put in 20% here, 20% transparency, save the script, our blue color will dim just slightly. If I set this to 90, then it will dim quite significantly. There we go. So that is how you get transparency from the inbuilt colors. So for example, if you were plotting the closing price here and you wanted to set the color to a transparent blue, or let's do a transparent green, this is how you would do it. You set the color to the color.new function, and then you pass in an inbuilt color or any color value for that matter. It doesn't have to be an inbuilt color. It could be a custom RGB color. But again, if you're using the color.rgb function, you can specify your transparency directly in there. So this is most used for applying transparency to the inbuilt colors that Pine Script offer. So now if I save the script, we are plotting, you probably can't see it very well because it's got 90% transparency. Let's change this to 50. We are plotting a green line onto our chart with 50% transparency using the inbuilt green color. The last color type that I'll show you how to work with is hexadecimal colors, but this is how you will mostly be working with colors in your script. You apply the color parameter to whatever shape, plot, background color, whatever thing you are drawing onto your chart that can take a color input. This is how you assign it a color, and this is how you assign it a transparency amount. So let's get rid of this plot and get rid of this, and let's specify our color using hexadecimal code. So before I continue, what is a hexadecimal color, you might ask? Let's go to Google. So hex colors are a way of representing colors from various color models through hexadecimal values. Now hexadecimal is just a mathematical term. You don't need to know what it means. All you need to know is that the same way we use the RGB function to specify our red, green, and blue values, hexadecimal does exactly the same thing, but it uses numbers and letters. So 0 is no color, F is full color, and everything in between these values is different shades. So we can count from 0 to 9 and from A to F. And then the way you specify your color is the first two values are your red values, or the first two letters or digits in your hex code is red, the second two digits are green, and the last two are blue. And I believe in Pine Script we also have access to another two digits which specifies your transparency. So you don't need to know how hexadecimal colors work in order to use them. So let's just jump back over to the Pine Script editor, and I'll wrap up this lesson by creating some hex colors. Before I do that, I should mention that there are several tools out there that you can use for picking colors. Just Google a color picker, and there's heaps out there. Find one that you like, and then all you need to do is click on the color that you see on your screen and then copy this code here. So let's go with pink and copy this hex code and jump into the Pine editor. And now let's paste in this hex color and save the script. Voila, easy. We have a nice pink background there using our hex colors. So again, let's just quickly go over these values. If I wanted a black background, all I need to do is 000000, save the script, and we'll get dark black. If I wanted white, it would be FFFFFF. Save the script. Now we have bright white, and I believe we can use transparency as well. So if I put in, let's try AA in here and save the script, see what happens. Yeah, that worked. So you can see that the white color dimmed a little bit. So you can specify your transparency with hex as well, using the same range of values, so 0 to F, or 0 to 9, and then A to F, with 0 being no transparency and F being full transparency. And so just to wrap up this lesson, let me just show you one last example. Let's change the background color to red. That would be FF0000, save the script. There we have a bright red. Let's try green. That would be 00FF, save the script, and we get bright green. So that's really it for colors in Pine Script. They're quite simple to work with once you get the hang of the RGB function or the hex function, whichever you're more comfortable with. If you're used to using hex colors in graphic design or web design, just stick with hex colors. For the most part, you'll probably be using the color dot and then the inbuilt colors here. I rarely use custom colors unless I'm doing a complex color scheme. Most of these inbuilt colors will do the job for most things that you do in Pine Script. Just remember that if you need to apply transparency to it, you need to use the color.new, then pass in the inbuilt color and then a transparency amount. Anyway, that'll do it for this lesson. I'll speak with you in the next one. Take care. Hey traders, welcome to the background color function lesson. For this lesson, we're starting with a blank script and I'm going to set overlay to true. Whoops, that's not true. That's true. So I'm going to set the overlay parameter of our indicator function to true. What this does is makes the script, whatever we draw out of our script, draw onto price action onto our chart. So I'm going to save the script and add it to my chart, make sure that works. There we go. We're plotting the closing price as a line over price action. And we're good to go. So for this lesson, I'm going to show you how to change the background color of your chart to detect certain candlestick patterns. And for today's lesson, we're going to be detecting inside bars. So any bar that has its high and its low contained within the previous bar. So this would be a good example of that. Here we have a bearish candle, and then the next candle prints within the bounds of that bearish candle, and therefore is an inside bar. Now we're going to cover price analysis in future lessons, so don't worry if this is getting a bit ahead for you when we start doing a little bit of price analysis here. So I'm going to create a new variable here called inside, and I'm going to set this to a Boolean value. And this Boolean check is going to say, is the current bar's high less than the previous bar's high? And is the current bar's low greater than the previous bar's low? So we're checking, is the current bar's high less than the previous bar's high, and is the current bar's low greater than the previous bar's low? That gives us an inside bar. And then in order to detect this inside bar, we're going to use the BG color function. Now, to tell the BG color function when to change color and when not to change color, we need to use a Boolean value. The way we do this is using what is called a ternary operator. Now, don't freak out. It sounds scarier than it is. A ternary operator, or a conditional operator or statement, is basically a true or false statement. It's saying, is X true? If so, do A. Otherwise, if X is not true, then do B. And this is what it looks like. It's a little bit like algebra. I know if you're anything like me, you hated algebra in school, but don't worry, this is extremely simple algebra. We're just saying, is X true? If it is true, do this. Otherwise, if it's false, do this instead. That is the best way to change the background color of your chart in Pine Script, and I'll show you how to do it right now. So we're going to say, is inside true? If so, set the background color of our chart to color.blue. Otherwise, set it to nothing, or NA. And the otherwise operator here is just a colon. So the way I've become accustomed to explaining this is through treating this like a question. So I say, is inside true? Question mark. If so, paint it blue. Otherwise, do nothing. NA means nothing. Don't do anything. Leave the background color alone. The background of our chart has done nothing wrong. We want to leave it alone. But if we have an inside bar, then we want the background color to change. We want to be notified that that is the case. So when I save the script here, we should get the background color changing for these inside bars. There we go. Perfect. Well, almost perfect. It's a little bit bright. I didn't expect it to be so bright. Obviously, transparency is set to 0 by default. That didn't used to be the case. Normally, when you set the background color of your chart, it was quite faint. But they've obviously changed that recently. And so that's fine. That's a good opportunity for me to show you how to add transparency to your background colors. Now, adding transparency to all of your drawing tools is the same method in Pine Script. We need to use the color.new function. And in this color.new function, we can pass in an inbuilt color. So in this case, we're working with the color blue. So we can write color.blue. Then we need to put in a comma so that we can pass in another parameter to this color.new function, which is the transparency amount as a percentage. So 100 would mean it's fully transparent. 0 would give us what we see here. So let's set this to 50 and see what it looks like. I'll hit save. There we go. That's a little bit better. Now it's a little bit easier to see the candles on top of the background color. And now our script is detecting all the inside bars that are printing onto our chart. It's really simple to do. Obviously, you need to learn how to use this little ternary operator thing, but with practice, you'll get the hang of this. It's actually quite simple. We will be using this a lot in future scripts, so don't worry if you don't understand this yet. It will come to you in time as you see more practical examples of it being used. Now, before we wrap up this lesson, let's have a look at the other parameters that the background color function can take. The next one is offset. So I've showed you offset in the plot function lesson, if you've watched that, and hopefully you have. All of these lessons build on top of each other, one after another, so make sure to watch them in order if you're new to Pine Script. But this offset parameter will just move the background color X amount of bars to the left or right. So if you put in a negative number, it'll move that many bars to the left. If you put in a positive number, it'll move that many bars to the right. So let's start with -1, for example. I'll zoom in right in here. Now these two background color candles will move or shift back 1 bar when I hit save. Watch this. Save. There we go. They've moved back. If we set this to 10, for example, now they'll shift 10 bars to the right. So hit save, and there we go. They're now shifting 10 bars to the right. If I scroll to the end of our chart, you can see that these background colors are way away from price action because they're being drawn offset by 10 bars. The next parameter that we can work with is editable, which I've showed you now a couple of times in the past few lessons. This just makes it so that the user cannot change the background color style in the style menu. As I keep saying, I don't know why you would want to do this, but you can if you want to. So I can set that to false, and now the user is stuck with whatever design choices I make, whatever color schemes I choose when making my script. So if you're a control freak, then maybe this parameter is for you, but I prefer not to use it. I like to give my script users as much control over my script as possible. The next parameter is show_last. So this is how many bars to show this background color on from the last bar on our chart. So if I set this to 10, we will only see these background colors being drawn, and anything 10 bars or more to the left in historical price action from the current bar will be no longer drawn. And then finally, the final parameter we have to work with is title. So this just titles our plot. So I could call this anything I want. I could call it how deep is your love, for example. And if I save the script, maybe some of you will get that reference. Here we go. Our background color is now changed to whatever we want to title it so that the user knows what this does. Obviously, this title is not very helpful, but you get the idea. In your own scripts, you would call this, for example, I like to use background colors for filters in my script. So maybe you could call this inside bar filter. And maybe you don't trade setups that occur when the background color of your chart has changed color, or maybe you only trade setups that occur within the shaded color on your chart. Anyway, that's it for the background color function lesson. I hope you found this interesting. If not, I apologize. The course will hopefully get more engaging and interesting as we progress. I just need to teach you all this basic stuff so that when we get to the more advanced stuff, you are well prepared with a solid foundation and understanding of how all these functions work so that we don't get overwhelmed when I start pumping out lines of code like this on the fly. I don't want you to be left behind. So as I've said before, if you're new to Pine Script, make sure to watch all of these lessons because they will be helpful in the future in terms of you understanding what's going on with more complex scripts. So that'll do it. I'll see you in the next one. Take care. Hi traders, welcome to the shapes lesson. In this lesson, I will show you how you can use the plot shape function to plot shapes directly onto your chart. So the script you see in front of you right now is almost a blank script. All I've done is I have written 2 lines of code here, created 2 variables, 2 Boolean variables, higher close and lower close. higher close will only be true if the current bar's closing price is higher than the previous bar's high, and lower close will only be true if the current close is lower than the previous bar's low. And then I have the plot shape function here that is plotting a shape whenever higher close is true. And that is what these blue shapes are on my chart. So you can draw shapes into their own box like we have here. I've got the overlay setting disabled. But for today's lesson, let's set overlay to true, and we will draw these shapes above and below the bars on our chart. So let me close this script and add it back onto my chart. And let's start playing around with the plot shape function. So the first thing I'm going to do is let's uncomment this second line of code here, and we'll be plotting X's above both higher closes and lower closes. So the first thing I'm going to do is I'm going to title these plots. So I'll call this a higher close and this lower close. The next thing I will do is let's change the style of this shape. To do that, we just type in style equals shape dot control space, and here is the list of inbuilt shapes we can use in our scripts. So I'm going to go with triangle up for a higher close and triangle down for a lower close. I need to fix that typo there. So higher close will be shape.triangle up. That's my favorite shape to use for detecting candlestick patterns. I usually use triangle up and triangle down to identify long and short signals in my scripts. I think it's the best shape for that. I'll explain why. Let's set the other plot shape to arrow down and save the script. So now we have these triangle up shapes for higher closes and triangle down shapes for lower closes. The reason why I like using triangles instead of the arrows is because of this. If I start scrolling out my chart, notice that our blue arrows have shrunk quite significantly, while our triangles are still the same size that they were when we were zoomed right in, or at least much closer. So the arrow shape does decrease in size as you zoom out. The triangle does so at a much less significant rate. So it's obviously a matter of preference what you use, but I'm going to go with triangle down for now. And just before we move on, let's have a quick sneak peek at some of these other shapes we have. We've got circles, we have crosses, and we have diamonds. What else? We have flags and label down. Let's see what they look like. So label down looks pretty cool as well for detecting long and short trades. That would not be a bad choice. We also have X cross, which is the default shape. So if you don't specify a style, the style will default to shape.xcross. But let's change these back to triangle up and triangle down. Now, the next thing I need to do is I want to move the triangle up below the bar, and notice that the shape draws above the bar by default. So technically we don't need to change the lower close location, but we do need to change our triangle up location. To do that, we just type the location parameter. So location equals location.control space, and here are our options. Let's go over all of them before we move on. First one is above bar. That's the default parameter or setting for this function. The next one is absolute. Let's see what that does. Save the script. Now our shapes are drawing at the very bottom of our chart. And I think what this does is it actually draws at the price you specify. So if I were to say here, high close question mark, draw the shape at 70,000, otherwise draw nothing. Let's save the script and see if I'm right about that. And yes, that is exactly what is happening. You can see that our shapes are now drawing at 70,000 here on Bitcoin. And so the absolute location uses a price value for when you plot the shape. But let's get rid of this and see what some of the other locations are. The next one is below bar. That's the one we want for this shape. But let's check these two out first. Bottom will put the shape at the bottom of your chart display down here. So no matter how zoomed out your chart is or how you've scaled your chart, the shapes will be drawn along the bottom of your chart. And same with top. Top will do the same thing, but at the top of your chart. Ta-da! So let's change this to bottom, below bar, and save the script. So now we are getting triangle ups drawing beneath higher closed candles and triangle downs drawing above lower closed candles. So that's exactly what I want to happen here. Obviously, we could specify location equals location dot above bar here if we want to, but that is redundant because this is the default setting for this shape anyway. So let's not do that for now. And let's look at some of the other parameters we have. The first one is color. So color works the same way as it does in all plots in Pine Script. We can set it to any color, so color.rgb, a hexadecimal color, or an inbuilt color if you want to. I'm going to set it to color.green since a higher close is technically a bullish pattern. And let's set our lower close to color.red since that is bearish. Save the script. And there we go. We now have green and red arrows. Before we move on, one other thing to mention is that you can apply transparency to your shapes if you want to. I could set my triangle down to 50% transparent, and now they're a little bit more faded. I don't think I've ever used transparency in my shape plots because if you're plotting shapes onto your chart, normally you want them to be as visible as possible. But the option to apply transparency is there if you need to, as it is with all plots. All functions that plot displays onto your chart in Pine Script, including tables. And I'm not sure about labels, but we'll cover that when we get to the labels lesson. So let's move on to the rest of these function parameters. The next one is offset. Now you should be familiar with offset by now. It applies the same way to all of our plots. Offset just shifts the plot X amount of bars to the left for a negative number and X amount of bars to the right for a positive number. And you'll have to excuse me, I get quite bored sometimes when I'm pumping out these lessons. I've recorded a lot of lessons today and I'm getting a little bit tired of my own voice. But let's move on. The next parameter we have to work with, as I said, is offset. Let's have a quick look at that. Before we do that, because this line is getting quite long, this line of code, it's not considered good practice to have your code go too far off your screen. Now, some of my scripts do this just because I like to keep my the lines of code in my script as short as possible, but it is not considered good practice to do that. If you're publicly publishing scripts, you may want to wrap this code onto multiple lines. So let me show you how to do that. And I think that's what this vertical line in the middle of our editor is for. You're supposed to keep your code to the left of this line, just so it's easier to read on multiple screen resolutions. I ignore it mostly in my own script. It's obviously optional to do that. But for now, let's wrap this code onto multiple lines. To do that, I'm going to start with this code here. I'm going to hit enter, tab, and then space. You need to add a space after your tab in order to avoid compile errors. If I save the script, this code works just fine. If I get rid of that space though, and I save the script, we get this weird error. I'm not sure why Pine Script have designed it to be that way, but just keep that in mind. So now that we have our tab and space, we can move all of these parameters onto their own line. And you can even move this bracket down if you want to. And so now we have all of our parameters separated onto their own lines. We'll do the same for this too, because we might as well keep this consistent. And now I'll just add some white space to the bottom of my chart and bring this up a little bit higher. And let's go over some of these other parameters. So the next one was offset. If I set this to, let's set it to 20. Save the script. We are now offsetting our higher close candles 20 bars to the right. So if I count out 20 bars here, this bar right here is drawing on this bar right here because that is 20 bars to the right. So that's what offset does. If you set it to a negative number, it'll shift it to the left. Let's get rid of that for now though. We'll have a quick look at text. Text is an important parameter because we could say here, HC, let's just do HC, short for higher close, and we'll do the same for our lower close. We'll set text equals LC. Now when I save this code, we'll be getting text drawing onto our chart. So this is a good way to visually identify different candlestick patterns. If you want to, it does add a little bit more clutter to your chart. So that's obviously a matter of preference, but we'll leave that in for now. Let's look at the next parameter, which is text color. So this changes the color of the text, obviously. Let's change it to color.white and see what that looks like. text color equals color dot white, save the script, and there we go. That actually looks a little bit better, I think. Let's keep moving on. The next parameter we have to work with is editable. Now, as you might know by now, if you've watched the previous lessons in this course, I don't like the editable parameter. I don't like restricting the customization of my scripts. I like my users to be able to do whatever they want, but if you want to stop your users from being able to edit the style of your shapes, so here we are on the style menu. Now that I've set our higher close plot shape to false, editable to false, we can only edit the lower close shape here. But I like to leave editable as true, which it is by default, obviously, because then the user can change what they want in the settings menu. So don't use editable unless you are a control freak. And let's move on to size. Size is also an important one. If I set size to size dot control space or command space on a Mac, here are our options. So by default, it is set to auto. All of our plot shapes are set to auto, which means they will scale with your chart zoom. If I set it to huge, let's see how big that gets. Save the script. And they're not wrong. That is a huge shape. It actually looks something like a drawing of mountains. You'd be surprised what you can achieve with a bit of boredom and playing around with some of these shapes and colors. You can get your charts looking pretty close to a Bob Ross painting. Anyway, let's have a look at some of these others. If I set it to normal and save the script, this is quite large still. But the whole point of being able to override the size is that if I zoom my chart right out, the shapes all stay the same size. Whereas if you leave it on the default auto, then the size adapts as you zoom in or out your chart. Let's just have a quick look at tiny before we move on. Doesn't look that tiny to me. I guess when you zoom in, it is. That's definitely much smaller. But as you zoom your chart out and the lower close shapes scale down because they're set to auto, they become a similar size. And in fact, if we zoom right out, they're bigger than our lower close candles, even though they're set to tiny, because the tiny is not scaling with our chart. And obviously the tiny size has more of an effect when you're zoomed in on your chart. So that is our size parameter. What do we have next? Show last and display. So show last is just how many bars to show this plot shape on over recent price action. So if I set this to 10, so we only have 3 higher closes here. So when you set show last to a given number, in this case 10, that means we are only drawing higher closes on the last 10 most recent bars on our chart. So that's what show last is for. The final one is display. So display, I believe this parameter is in most plots, if not all of them. So plot shapes, plot characters, the standard plot function, anything that draws a shape or a line onto your chart, you can set display to display dot, and then here are your options, display.all or display.none. By default, it's set to display.all. If you override it to display.none, then all of our higher close shapes will disappear. And the only way to get them back is to come up to the settings menu and tick this little box to display this shape. So if I click that, all of our higher closes come back. If I tick them both off, they are both set to display.none, and we have nothing drawing onto our chart. So that is it for the plot shape function. We will be using this quite frequently in our scripts. I use the plot shape function in all of my setup detection scripts, so you'll get quite used to this function throughout the course. I rarely use more than a few of these parameters, but the course wouldn't be complete without a complete rundown of the available options to you. So that's what this lesson was. I hope you found it interesting, and I will see you in the next one. Good luck with your coding. Good luck with your trading. Speak soon. Let's have a look at one of the most simple technical analysis conditions we can check for in Pine Script, which is moving average crosses. Now, this is not a trading lesson. I do not encourage you to trade moving average crossovers and cross-unders. They may be profitable with the right rules, the right set of rules and entry reasons, etc. I personally don't trade them, but for the purposes of this lesson, they are a great example of how easy it is to detect certain market conditions in Pine Script. So to get started, we of course need 2 moving averages in order to detect a cross. So let's get some MAs. And again, just today, because it's my favorite moving average, I'm going to use an EMA, an exponential moving average, but you can use any moving average type you like. I'm going to set EMA1 to TA.EMA, and we'll base it on the closing price as always. And this one will have a length of 50. And then the second EMA will have a length of 100. So now before we proceed, let's draw the MAs onto our chart. And I will style the first one with the color green, and the second one can be red. So let's save the code, make sure that this is working fine. There we go, 2 moving averages on our chart. Now, let's detect our crosses, our crossovers and cross unders. So we'll create 2 variables here, 2 new variables called MA crossover and MA cross under. Now for our crossover and cross under, we're going to use the inbuilt function, TA dot, and then if I start writing cross, here we have our various options. Now cross will detect either a crossover or a cross under. For today, we're going to separate these two into their own variables. And so for crossover, I'm going to use crossover, obviously. And for cross under, we'll use TA.cross under. And now these functions take 2 parameters, 2 values that need to cross. These could be any values. They don't need to be moving average values. They could be anything. MACD lines, for example, or the RSI crossing over a certain threshold. For today, we're just going to put in EMA1 and EMA2. If I copy that into our second function here, we are now detecting our MA crosses. And at the bottom of our script, I'm going to draw crosses. And here I'm going to set BG color to MA crossover, question mark. If the moving average has crossed over the other moving average, if EMA1 has crossed over EMA2, I'll set the background color to color.green. Otherwise, I'll do nothing with the background color. Set it to NA. I can copy this line of code, paste it underneath, change this to cross under, and we'll change the color to red. And now, if I save my script, we'll be getting the background color of our chart changing based on which cross happened. So click save. And that will do it for this lesson. Very simple one here. Just, again, introducing you to the TA namespace and combining some of the things we've learned so far to create practical indicators that can be actually useful in our trading. Anyway, I'll leave this one here and I'll speak with you in the next lesson. The source code will be below if you want to play around with this. Hey traders, the next 2 lessons to wrap up this free Pine Script Basics course have been taken directly from the Pine Script Mastery course. My intention here is to leave you with something practical and useful that you can go away and play with in your own Pine editor, and also to show you the kind of content that will be throughout the Mastery course if you're interested in taking the next step with your Pine Script journey. As I mentioned at the beginning of this course, you can learn everything that I've learned without paying for any courses. I learned everything I know about Pine Script through trial and error, practice, and reading the official documentation, and just breaking down other people's scripts. But that process took me 3 years to get really proficient with Pine Script. So if you want to really save time, which I think is our most precious resource as traders, we can always make more money, but we do not get more time out of life, no matter how rich you get. So if you want to save time and really speed up the learning process, cut all the crap and just learn exactly what you need to know in order to go out and build useful, practical trading tools and profitable strategies, then when you're done with these last 2 lessons, go and check out the Mastery course, see if it's something you'd be interested in. I now have a monthly subscription option for that course, so even if you just sign up for 1 month, go through some of the content, see if you like it, I guarantee you it will not be a waste of money. And if you feel it is a waste of money, I'll refund your first month completely. I'm confident in the quality of the course and the content that I teach. I'm only teaching you the things that worked for me in my own coding and my own trading. And so I stand by the quality of the Mastery course. And if you want to check it out, there is a discount code you can use to get 10% off your first month in the Mastery course or lifetime access to the Mastery course. This code works for both payment plans. The Mastery course is an ongoing project of mine. I plan to expand on it significantly over the months to come for so long as I'm a trader and I'm working with Pine Script. The price is likely to increase over time as I put more work into it. So now is a great time to lock in the current price and a discount if you are ready to invest in your future as a Pine coder and a trader. With all that said, let's get started with the final 2 lessons of this course. I hope you find it interesting. Good luck with your trading and your coding. I hope you make tons of money, and most of all, I hope you have fun and enjoy yourself, as much as I have throughout my own trading and coding journey. For this lesson, I thought it might be interesting to detect candlestick patterns when the RSI is overbought or oversold. So what you see on your chart right now is a script I've written that is drawing the RSI into its own indicator box here. And whenever the RSI goes oversold and we get a bullish engulfing candle, we get this bright green background drawing onto the chart. And likewise, whenever the RSI goes overbought, the line turns red. And then if we get a bearish engulfing candle, the chart turns red. The background of our chart on that bar turns red in our indicator box. Let's open up a blank script and get started. So here I am with a blank script drawing nothing onto the chart. I've set overlay to false, or at least I haven't overridden it to true so that we are drawing into our own box. Let's get started. The first thing I'm going to do for this particular script is import my Zen library. Now this is completely optional. I'm only doing this to save time. My Zen library contains some candlestick pattern detection code that will just save me time in not having to write that code out in this lesson. If you want to write out your own candlestick detection code, definitely feel free to do that. But for today, I'm going to import my Zen library using the import keyword and control space. I'm just going to click on this and import it as Zen. So now we have the library imported. The next thing to do is get some user input. I'm going to get 4 inputs here. I'm going to get a look back. I'm going to get an RSI length, an RSI overbought, and an RSI oversold level. And then I'm just going to fill these out one by one. So look back is going to be set to input.int. It's an integer, and it's going to have a title of just look back and a default value of 7. And I'll show you what the look back is for later. The next value we are getting is an RSI length. So again, input.int title equals RSI length. And the default value is also going to be 7 for this particular script. The code for today's lesson is based on a strategy that I've traded in the past that is profitable. And so I'm keeping the same parameters that I used for that strategy, which are slightly different to the default inputs. We're dealing with a 7-period RSI instead of a 14-period. And we're dealing with an overbought and oversold level of 80 and 20 instead of 70 and 30. But anyway, let me write this out. I like to use floats for my RSI overbought and oversold level because it gives the user slightly more control over the value. So for this, I'll set it to 80.0. And for my oversold level, I can copy that, rename that 80 and 20. And those are our user inputs that we need for today. And so now if I save my code here and I open up the settings menu, you can see that we can set the RSI overbought and oversold level to anything we want. You can set it to 20.5 if you want to, instead of the usual whole number setting. But for now, we'll leave it as it was. The next thing I need to do is get the RSI value. For that, we use the inbuilt function ta.rsi, and this function takes a source and a length. So I'll pass in our RSI length setting into this function, and now we're getting our RSI value. The next thing we need to do is check if the RSI is overbought or oversold. So for that, I'm creating 2 new variables here called RSI sell and RSI buy. RSI sell is going to be set to is the RSI greater than RSI overbought, or 80 by default. Is our RSI value greater than 80? If so, RSI sell will be set to true. And for buy, it's the opposite, RSI less than RSI OS. So is the RSI less than 20 by default, our oversold level? Now we can use these 2 variables later in the script to tell the script when to draw signals onto the chart. But before we detect our signals, we need to get our candlestick patterns. So here I'm going to say detect candle patterns. As I said at the start of the lesson, you could write your own code here to detect whatever candlestick pattern you want. I'm going to just stick with bullish and bearish engulfing candles, as that is what the strategy was based on originally. So I'm just going to reference my library, zen.isBullish engulfing candle. And I'm not going to override any of the function parameters for this engulfing candle. Same with bear EC, zen.isBearish engulfing candle. Now we have our bullish and bearish engulfing candles. The next thing to do is detect buy and sell signals. And that's quite simple. All we need to do is check, is the RSI overbought or oversold? And do we have one of our relevant candlestick patterns? So here I can set up two new variables called buy signal and sell signal. And buy signal is going to be set to, do we have a bullish engulfing candle? And then I'll open up some parentheses here. I want to check, is the RSI currently oversold? Or was it oversold on the previous bar? Because quite often, especially in the case of bullish and bearish engulfing candles, sometimes the engulfing candle will close and bring the RSI up out of our oversold level of 20. But the candle before it was below 20. That just scared the hell out of me. I've got my headphones turned up to maximum volume so I can hear that the audios are okay, and that was so loud. What was that? Oh, good, one of my trades is doing well. I'll check on that after this lesson. Let me write out the code for this. So we're detecting our bullish engulfing candle. The next thing to do is check, is the RSI buy variable true? So is this condition true? Or was it true on the previous bar? So was the RSI oversold on the current bar or the previous bar? And we got a bullish engulfing candle currently. Then we have a buy signal. Very simple strategy here, but very powerful, especially when combined with market structure. So if you drop out to a higher time frame and you get one of these signals around a support and resistance zone, it can be a very, very effective counter trend trading strategy. Now for our sell signal, we do the same thing. Do we have a bearish engulfing candle? And was the RSI sell variable true? So is the RSI overbought, or was it overbought on the previous bar? Was RSI sell true on the previous bar? If it was true on either of these bars and we have a bearish engulfing candle, we have a sell signal. That's really it. All that's left to do is draw the data to the chart, and I'll also generate an alert when one of these conditions are true. I'll show you guys how to add alert functionality to your signal detection. But for now, I'm just going to copy my plot code because you've already seen me write these plot lines of code out a million times. Hopefully by now you understand how it works. We're just plotting the RSI overbought and oversold level, and changing the background color when we have a signal. So we're plotting the RSI. Let me save this code really quickly so that I can demonstrate this visually. So we are plotting the RSI line here. And let me change it from black to gray so we can see it a little bit easier on this background color. There we go, that's a bit better. So when the RSI buy is true, meaning the RSI is oversold, we change the color of our RSI line to color.lime green, or bright green. Otherwise, if RSI sell is true, meaning the RSI is overbought, then we change the RSI line to red there. Otherwise, if the RSI is neither oversold nor overbought and it's just in the middle of nowhere, then we set the color to gray. And then we set the line width to 2 to thicken it up a little bit. We plot our RSI overbought and oversold levels. In fact, I think a H line will look better here. So let's change these to horizontal lines. H line plots, save my code. I think this will look a little bit better. Yeah, there we go. I like that better. And then finally, we change the background color of our indicator box based on whether we have a buy signal or a sell signal. So similar to how we change the RSI color based on these two variables or conditions, we do the same thing here. We say, do we have a buy signal? So is the RSI oversold, or was it oversold on the previous bar? And do we have a bullish engulfing candle? If so, we set the background color to green or lime. Otherwise, if we have sell signal is true, so we have a bearish engulfing candle and the RSI was overbought or oversold on the current bar or the previous bar, then we change the background color to red. Otherwise, if neither of these conditions are true, we set the background color to NA, or in other words, we just leave it alone and it gets set back to whatever our default setting is in our TradingView settings. And that's it. We have a strategy, essentially, a tool to help us trade a strategy built out in Pine Script. Now, the final thing to add more usefulness to this tool is to add alert functionality. So let's do that down the very bottom here. Let's trigger our alerts if any of our conditions are met. To do this, I will use the alert condition function. And here we need to say, for our condition, do we have a buy signal or a sell signal? If we have either a buy signal or a sell signal, then we want to generate an alert to our phone, to our charts, to our email, however you like to set up your alerts. And we need to title this alert, so let's call this just RSI signal. And we also need to give it a message. So for this, I want to say, we need to name this setup. So I'm just going to call it RSI exhaustion setup for, and then we can open the two curly brackets and then put ticker in here and then close those two curly brackets off. And now our alert, when it gets fired, this ticker placeholder, that's what this is, the two curly brackets followed by a label in the middle will be replaced by TradingView with the ticker, so the market that we have set the alert on. So in this case, this would say RSI exhaustion setup for euro dollar or EUR, and it would replace the ticker name there. One other thing we could do here is include the RSI value so that we know just how overbought or oversold the RSI was on this particular bar. To do that, we can open up two curly brackets and put in the plot underscore 0 placeholder and then close off those two curly brackets and then close off my parentheses. The parentheses are optional. You could put a dash here as well if you want. Maybe that's a little less confusing, less braces and brackets going on in our code. And now what Pine Script will do is it will replace the plot here, plot underscore 0, is the very first plot value in our script. So in this case, that is this plot here, the RSI value. So when this alert fires, this placeholder will be replaced with, for example, on this particular bar here where my mouse is, it would have been replaced with 60.41009. But anyway, that sums up this script. So we have 35 lines of code, most of which is spaces and comments, and we already have a useful, practical trading tool that we can use in our trading. Now, I wouldn't recommend you go out and blindly trade this system. It can be quite effective. As you can see here, it does detect a number of, that would be losing trade, winning trade, losing trade, losing trade. But depending on how you trade this particular strategy, if you combine it with other filters such as market structure, you can get some really nice trading setups out of this kind of tool. Oh, and I nearly forgot to mention, the way you set alerts on this script is you need to come up to the alert button here or press Alt-A on your keyboard and select our script. So RSI oscillator is what I called my script. Click on that and then select the RSI signal in the conditions drop-down box. And then whatever you set up here will dictate how that alert fires. If you set it to once per bar, the alert will fire even before the candle closes. So you might get a lot of false signals firing alerts. That can be useful though if you want to be notified of a potential trading setup before it happens so that you're not in a rush to get your trade sorted once that signal is confirmed. But if you're proficient with your trading process and you can place trades really quickly, then you just set it to once per bar close and you'll be notified as soon as the signal is confirmed and the bar closes as a valid signal. Anyway, that will do it for this lesson. I'll speak with you in the next one. As always, the source code will be below. What's up, my friends and fellow traders? Welcome back to another lesson. In this lesson, I'm going to show you how to convert the previous lesson's indicator, this RSI oscillator indicator, into a script that draws onto price action and shows you your stops and targets. Now, as I mentioned in the beginning of this course section, in the introduction to the technical analysis functions, you cannot draw over price action and into your own indicator box in the same script. You need two different scripts in order to achieve that. And in this lesson, I'm going to show you how we can basically copy and paste all of the code out of this lesson, this script that we created in the previous lesson, into a new script and adjust it slightly so that instead of drawing the signals like this, it actually draws our stops and targets over price action. So first of all, before we start, if you haven't watched the previous lesson, you probably should, because I'm not going to cover what all of the source code here does in this lesson since I already did that. So if you did skip ahead, make sure to go back and check that out if you want to know what's happening here with the code. Because right now, I'm going to copy all of this code into a new script called RSI I'll just call it RSI chart signals and tidy this up a little bit. And for this script, I am going to set overlay to true. I'm going to paste in all of our source code here. I'm going to comment out our plots and set the plot down here to NA, just so that the script compiles. And I need to get rid of this duplicate indicator annotation function. So here we go. We basically have our same script that we were working with in the previous lesson, drawing over price action. Same core logic of the script. The guts of the script is still the same. The main difference is we're drawing over price action, and I've commented out all of our indicator box plots because we're not going to be using these in today's lesson. So I can get rid of all of these. We can leave the alert condition function in there. There's no reason not to generate alerts here for this script. And now if I save the script and add it to my chart, we now have our script drawing over price action, but we're not actually drawing anything yet. To draw what we need onto our chart, we need to get a couple of other values. I'm going to add another input parameter here called multiplier, and this is going to be our stop loss multiplier. So it needs to be a float, and we'll call this ATR multiplier. We'll give it a default value of 1.0. The next thing we need to do is get the ATR value. I'm going to be using ATR-based stops and targets for this particular script. So for that, I need to get the ATR from the ta.atr function. I'll just use a default 14 period length. And now that we have the ATR and we are detecting our candlestick patterns, all we need to do now is calculate our stops and targets. So down here, I will say calculate stops and targets. And here is where the magic will happen. So for a long stop, we'll have long stop and short stop. For long stop, because we're trading bullish engulfing candles, what I might do is subtract the ATR from the lowest low over the past. Now, in the previous lesson, I forgot to mention that this look back setting is not actually used in the oscillator version of our script. But we are going to use it in this version of the script. And what we are going to do is we're going to use this look back period to specify how far back to look over price action for swing lows and swing highs to base our stop loss on. So by default, it's set to 7. So the script will look back 7 bars for the lowest low in the case of a bullish trade and add 1 ATR to that low to give us our stop loss. For our long stop, we need to get the ta.lowest low over our look back period. And then we need to subtract the ATR value multiplied by our multiplier. And that will give us our long stop loss price. And now we can do the same thing for short stops. We need the ta.highest high over our look back period plus the ATR multiplied by our multiplier. Now, let's plot this data to the chart. The first thing I'm going to do is use plot shape to plot when we have a buy signal, and plot shape to plot when we have a sell signal. I'll give this a style of shape.triangle up, and a color of color.green, and a location of location.below bar. I'm going to copy this code, change this to red and this to down, and this to above bar. So now we should be drawing, if I save my code, we should be drawing arrows above and below our bearish and bullish signals. So far, so good. The next thing to do is to plot our long stop and short stop. So for that, we can say plot, and then we need to check, do we have a buy signal? Question mark. If so, plot our long stop. Otherwise, plot nothing. And we'll give this a color of color.red since it's a stop loss. And we can copy this line of code and put in sell signal here and short stop. And now if I save our code, we should be getting our stop loss drawing above and below our signals, which you can see there. If I zoom right in, you can see our little red line there. That is our stop loss. So we enter at the close and our stop loss is this far away. And if you hover over the setup bar here, you can see the exact price that we need to set our stop loss to, which is extremely helpful when entering trades into your trade panel. But anyway, so now we are drawing our signals onto the chart. We are drawing our stop loss for each setup.
All that's left to do is draw our take profit. Now to do that, I need to create two new variables here called long target and short target. Now to make it easier to calculate these values, I'm going to create another two variables here called long stop distance and short stop distance. And this will be the distance in pips or points from our entry to our stop loss on both bearish and bullish trades. And to get that value, I simply need to subtract our long stop from our closing price, which is our entry price. Or in the case of a short stop, since the stop loss is above the close, we need to subtract closing price from our short stop in order to get a positive value. Now, to get our target, we just need to add the long stop distance to our closing price for long trades, or subtract it for short trades. So I can now copy our stop loss draw code and change this to long target and short target. Change the color to green since it's a take profit value. And now when I save my script, I should be getting a green line. There we go. Drawing 1-to-1 from our entry to our stop up to our target. There we go. Perfect 1-to-1 risk reward profile. Let's make sure the short trade is the same. And there we go. Perfect. So that's pretty much it for our script. The final thing to do is just add our risk reward profile setting into the mix. That's really easy to do. All we need to do is add some parentheses around our long stop and short stop distance and multiply this value, this distance value, by our risk reward setting. So now when I save my code and I minimize the editor, if I tweak my risk reward profile, let's try it 2-to-1. Now our take profit extends while our stop loss stays in place. And that's about it for this lesson. The source code, as always, will be below the video if you want to play around with this code. You could try detecting other candlestick patterns. You could see how hammers and stars or even doji candles perform with this sort of technique. One last thing I'll do before we finish this lesson, if I zoom out my chart a bit here, you can see we have these lines connecting all over the place. I forgot to set our line style on our plot, on our buy and sell signal long on stops, our stops and targets code, to line break. So we need to add on the end here, style equals plot dot control space style line break. And this will break the line between signals. So what you're seeing here is we have a long trade here and a long trade here. TradingView is connecting the lines between signals because I didn't set the style to line break. So now if I copy this down across all of our plots and save my code, all of these lines will go away. There we go. So now we just have the stops and targets drawing above and below the relevant signals. All right, I think that will do it for this lesson. I'll speak with you in the next one.
If you'd like to learn more about Pine Script, check out our website. I have a completely free 6-hour Pine Script basics course there, which explains the core fundamentals of Pine. And if you want to take your coding skills to the next level, check out my mastery course. We have over 50 hours of content and 50 plus 5-star reviews and growing. The Pine Script mastery course also comes with support where I can help answer any questions you have about Pine Script coding. And of course, there's tons of free content on my YouTube channel. So if you're new to Pine Script, go and check that out too.